and welcome, I'm your Code Monkey. Alright, so here let's learn the most valuable skill of all. Let's learn the skill of problem solving. So this is really the core skill behind anything that you want to build, basically any game or any system you'd like to build. For example, how do you build a health system? The answer is really you break the problem down into its core components, and then really just implement those one by one. If you do that step by step, you end up with a health system. The same can be said for literally any other system you'd like to build, or literally anything you want to build. How do you make a first-person shooter? How do you make an RPG or a puzzle game? Or even how do you make a website? How do you make some random program? How do you make some kind of electronics project? How do you make some kind of robot? The first step to taking all of those ideas and making them reality is indeed problem solving. I will talk more specifically on what exactly problem solving means in the first lecture in the course, and the reason why I say this is the most valuable skill you can get is because if you look at pretty much any kind of high-paying job, like some kind of engineer at a top company, one of the skills required will always be problem solving. So learning this one skill and getting better at problem solving, that will open up so many more possibilities for you. Now importantly, this is not a course on making a game step by step. No, instead this course is focused on teaching you how to think through and how to solve problems. So this is basically a course on the part that you don't really see in the tutorials. Basically all the thinking that goes behind the system is actually built. And this is also an extremely practical course. This is not something that you just watch casually and learn. No, in order to get this super valuable skill, you do need to actually put in the effort, you do need to actually put in the work in order to learn it. So this is a very practical hands-on course. The included companion project is key for learning the skill. You must actually do this in order to learn. And if you do all the exercises included in the companion project, if so, you will gain the skill. Also importantly is how this is more of an intermediate/advanced course. This is definitely not for beginners. So if you are a beginner, if so, then really focus on learning the basics first. Make sure you get a good solid foundation before you worry about things like this, problem solving. If you are a beginner, you can start from learning from my beginner courses. Either you can start with my Kitchen Chaos course, that is a great beginner course on making a nice 3D game, or alternatively, you can watch my 2D beginner and Little Lander course. Both these are great game making courses, specifically on teaching you how to make a game. They take you step by step from the completely empty project until the final polished game. And then also make sure you go through my C# course. You do need a very solid foundation of knowledge in order to be able to learn a more advanced skill like problem solving. If you are still having issues with basic syntax errors, if so, then yep, you really do need to focus first on learning those fundamentals, and then you can learn about something much more valuable like problem solving. But if you are at least on the intermediate stage, if so, then yep, this course for you, and it will teach you a super valuable skill. Also, as I said many times, I'm a huge believer in free education. Basically, I always think back to myself when I was 10 years old, and I basically had no money, but I did have the desire to learn. I wanted to learn programming and learn how to make games. Again, I really had literally no money as a kid, so paying for something was literally just not an option. Thankfully, the only way that I could learn was by basically going on Google and finding all kinds of random blog posts and random tutorials that people have made. So nowadays that I make educational tutorials myself, I want to make sure that a kid nowadays, just like I was back then, I want to make sure that same kid nowadays does have access to high quality education for free. That is why I try to publish most of what I do either completely for free or with a substantial free sample. I've got an entire page that by now already has 8 complete free courses. This one over here, problem solving, this one is a much more advanced course. Like I said, it is not a step-by-step course on making a game. It is not targeted for beginners. It is nothing like that. It is something very much more special, very much more niche. So for this one, I don't think it makes sense to do the whole thing for free. And actually, in order for me to be able to continue to afford making all kinds of free education for hopefully decades in the future, in order for me to basically do that, I do need to be able to make some paid stuff. So over here for this course, I decided that I'm going to put out a pretty substantial free version, which is this video you're watching right now. And then if you want the whole thing, you can pick up the full premium course with a link in the description. The premium version contains over 200 practical technical problems. Those are right there for you to solve. Those exist alongside 15 unique scenarios that each have their own design problem solving lecture. It also includes the other bonuses like the live chat window. Basically, I try to be online as much as possible, and I'm there to help you in real time exactly as you're going through the course. Then of course, the paid version also has priority QA. I try to answer all those questions within 24 hours. It also grants you access to my private Discord and private live streams that I do every single weekend. So if you can't afford it and you like what you see in this free video, if so, go ahead and pick up the premium version with a link in the description. But if you can't afford it, then that's fine. I really hope you'll learn a lot from this free video. And as a simple thing, if you want to thank me for giving you this awesome free knowledge, if so, you can just go ahead and like the video and subscribe to the channel. It's a tiny thing that doesn't really cost you anything, but it does help on the YouTube algorithm. Alright, with all that said, let's start learning this super awesome skill. Hello and welcome, I'm your Code Monkey, and welcome to my problem solving course. The goal of this course is to teach you the most valuable skill you can gain. It generally is the skill that allows you to get 6-figure jobs. And importantly is this course over here is focused on teaching you something that you never see in tutorials. When you watch some tutorial on some system, when you do that, you are watching the person explain how to build that system. For example, define a class, implement some kind of function, do some kind of logic. And if you do those step by step, you'll actually end up building the final thing the tutorial says. So the tutorial does explain how to build some kind of system step by step, but what you are not seeing is how that system actually first came to be. How it went from an idea on someone's head to an actual implementation that actually physically exists. You're basically not seeing all the problem-solving work that happened before that video. You are not seeing all the research, all the multiple approaches, all the errors and all the things that didn't work on the first iteration. You don't see any of that. You're really only seeing the final polished code. That's actually one of the issues with tutorials. And because of that, many people, especially many beginners, they don't really understand how behind a 20-minute tutorial, there might actually be several hours of research. When you see a 20-minute tutorial, it absolutely did not take just 20 minutes for that person to learn how to make that the first time and make the video teaching it. You are seeing just the final sliver, just the final version. Basically, after all the research, after all the problems, after all the refactoring, after all of that has been made, you're really just watching the final output, which is just a tiny portion of everything that is involved in pretty much taking any idea that you have and making it a reality. All of that happens before that, all of that is basically problem solving. And problem solving in two ways: design problem solving and technical problem solving. Problem solving in general is how you take a rough idea, like let's say I want to make some kind of inventory system, and how you come up with all these steps by step in order to achieve the final vision. Problem solving is also how, when you first implement your inventory system, you will undoubtedly encounter all sorts of issues, whether it be syntax bugs, C# errors, or behavior things that just don't work exactly as intended. Those are all problems that you do need to solve. You will never ever write a 100% bug-free system the very first time. So problem solving is without a doubt one of the most valuable skills you can acquire. How you can take something that starts as just an idea in your head and actually implement it, actually make it come to life. Or you take something that already exists but has some kind of problems and you have to figure out how to fix those problems. So you have this a super valuable skill in programming, but also just in life in general. Learning how to look at a problem and being able to figure out all the steps you can take step by step in order to fix that problem. That is an insanely valuable skill that can be applied to literally anything. And like I said, if you look at six-figure jobs, if you look at those, you will see how usually one of the requirements is being good at problem solving. This is a very valuable skill. Someone who can solve problems, who can find solutions, that someone is a very valuable asset. And of course, that asset is usually very well paid. Not to mention how it's actually not binary. Problem solving is not something where you either have it or you don't. No, it's something that you learn and you get better at it bit by bit. There's basically levels to it. And the better you become in problem solving, obviously, the more valuable you become, the better you become. If you are a beginner, then perhaps you might not even know how to solve some problems. And then if you have some experience, you might be able to solve some problems. But for example, a problem might take you hours or days to solve. Whereas as you become more and more experienced, then solving problems, the same problems that would have taken you days in the beginning, all of a sudden take you just minutes. This is something you will definitely be able to see for yourself. If you solve every single problem in this course, there are over 200 of them, and if you do, you won't be able to see how in the very first ones, it will probably take you quite a bit to learn how exactly to solve those problems, but after you've gone through, let's say 200 of those, if you go back to the first one, you will be able to solve it in literally just seconds. So problem solving is an awesome, super valuable skill, but it's also an extremely difficult skill to teach. In general, this is something you really only gain with experience. There aren't really that many shortcuts. You just need to solve tons and tons of problems, and by doing that, you will become better at problem solving. I've wanted to come up with some way to teach problem solving for many years, but it is very tricky. However, finally, after many years, I think I found a way. So over here on this course, I've created a ton of scenarios with a ton of problems, literally over 200, all of them handcrafted by me, with the goal being that if you solve all these problems, you will gain this super valuable skill. And these are based on actual problems that I've seen myself. These are all handcrafted by me. These are based on things that I've encountered myself over the past 25 years that I've been writing code, that I've written literally millions of lines of code. I've encountered all sorts of problems just like these, and by solving them is how I managed to actually get good at problem solving. And now I've condensed all of those 25 years of knowledge, condensed them all into one course. So if you go through all of these, if you do all of these, you will gain this super valuable skill much faster than it took me. In this course, there are both design problems and technical problems. For example, how do you make a health system? How do you go from that idea in your head, I want to make a health system, how do you take that from an idea and really make it work, make it actually exist? Even on something as simple as that, as a simple health system, even with that, there are still lots of questions you need to ask yourself. There's lots of decisions you need to make in order to turn this relatively simple thing and make it a reality. And then, given that same health system, like I said, you will never write 100% bug-free code the very first time. So given that, you are definitely going to encounter some technical problems, like let's say the bullets are healing as opposed to dealing damage. How do you actually manage to fix those problems? All of those interesting problems, whether they be syntax problems or behavioral problems, those are definitely things you are going to encounter quite a lot. So how do you learn how to solve those? Again, problem solving is how you get better at it. In this course, I will give you my 2 frameworks for pretty much solving any kind of problem you want. You can apply these 2 to literally any kind of problem and be able to find a solution. This course includes over 200 problems for you to solve. If you complete all of them, you will gain an insane amount of experience, which will allow you to gain this super valuable skill in a very short amount of time. And actually, a fun side effect of me building so many problems that are over 200, a fun side effect of that is since there are so many, you will definitely not remember them all. Meaning, you can go through all 200 problems, then if you want, after the end, you can go back, go back into problem number 1, solve that one, then solve problem number 2, and so on. Since there are so many, you will not remember what is the solution, so when you get back to the first problem, you will not be solving it based on memory, you'll be solving it based on your own problem-solving skills. Meaning this course is also pretty much an infinite training area. You can loop and constantly go through these over 200 problems over and over and over again, and every time you do, you will gain a little bit more experience, which again allows you to become quite a bit better at this super valuable skill. And if you do this, then especially as you go through the second run around, you will be able to see how you manage to solve each one of these problems much faster than the first time you did them. For me, like I said, it took me over a decade to get to where I am today. I'm at the point where I can solve pretty much any problem I can find. Any idea that I have, I know I can build it. My main limitation is really just time. But that is a super valuable skill to have. Being able to know any idea that I have, I know I can make it a reality. So my goal and my hope is that by following this course, by actively applying all these things, by actively doing all these exercises, you gain this super valuable skill in much faster than the 25 years it took me. Now keep in mind, this is not a normal course. This is not a course on making a specific game or building some kind of specific system. There are tons and tons of tutorials that teach you how to do all kinds of specific things. I have a lot of those myself. If you just want to learn how to make just a simple game or just build a simple system, if so, there are plenty of tutorials, plenty of courses for that. Whereas this course over here, this one over here, the goal is to learn the skill of problem solving itself. And like I said, this is something you only gain with experience. I cannot force feed you this knowledge. I cannot pass this knowledge on to you by just watching a video. You have to actually take action yourself. So you are expected to pause this course a lot and write a lot of code. This is not something you can just watch passively. If you are not willing to put in the effort to actually apply yourself, if not, then this will not work. You cannot gain the skill just by watching the lectures. All the lectures contain points in the video where I tell you when to pause the video and when to actually try solving it yourself. The lectures and all the problems, they all have their full solution available. There are walkthroughs for literally every single problem in this course. And in those walkthroughs, I basically solve the problem myself and I talk about my step-by-step process as I do it. But, and this is the very important part, you have to actually try solving the problem yourself. If you just see the solution, if you don't try at all, then it won't really work. You won't gain this super valuable skill. So I really hope you take this very seriously. Like I said, sadly, it's not really possible for me to transfer my knowledge from my brain onto yours. I can't do that just through a video. You have to actually apply yourself if you want to gain this super valuable skill. So hopefully now you understand just how valuable this skill is and how it's actually worth putting in the effort. So that said, let's continue with this course and learn this super awesome skill. Hello and welcome, I'm your Code Monkey. Alright, so here let's learn how to solve any problem of any kind. Specifically, I will teach you my two problem-solving frameworks. There's one for how to solve design problems and one for how to solve technical problems. By following these two simple frameworks, you'll be able to find solutions to any problem you can find. Now this lecture over here, this one is focused on teaching you the theory behind these two frameworks and how to solve these problems. But like I said previously, this is a very practical course. So here we're going to learn the theory, and then right away we're going to actually apply it to some actual practical problems. And after doing enough problems, then basically this framework right here, this will become second nature to you. You won't need to memorize the steps, you will really just remember all the things you need to do to basically solve any problem. Okay, so in general, there are two types of problems that you're going to encounter as you try to make literally anything. You have design problems. So these are, for example, how exactly do you design something? How do you come up with some idea and then actually figure out how you could implement that idea? And then you also have technical problems. So basically, how do you solve a practical problem? How do you actually fix it? For example, a sort of design problem would be, let's make a health system. Many games have all kinds of health systems. If you want to implement that into your game, you have to take basically that rough idea, health system, and break it down into its core components that you actually need to create something that actually is a health system. An example of a sort of technical problem would be something like, let's say the health system, when it takes damage, instead of reducing the health amount, it's actually increasing. So how do you figure out to solve that problem? That is basically using the technical problem solving framework. So first, let's look at how to solve design problems. So here's my 4-step problem solving framework. Let's go through it step by step. So the first step is to identify the problem. This is always going to be the first step in solving any problem. First, you need to have clarity on what exactly you're trying to do. So for example, let's say I want to make a health system. Then the first step is to identify what exactly does that mean? What is a health system? Usually in games, it means you have some sort of hit points, and then you can manipulate those hit points in various ways. So that would be step 1. Then step 2 is to break down the problem into its core components. This is how you take, for example, a health system and think about all the core components that it needs. For example, it needs probably the ability to deal some damage. It probably needs the ability to heal something. Then it also needs to store some kind of amount for your hit points. Perhaps it also needs to deal with the concept of death when it reaches 0. Perhaps it needs some kind of maximum. So yep, that's step 2. Basically take from a high-level overview, what is a health system, break down into its various core components. Now the trick here in step 2 is to basically break it down as much as possible until you cannot break it down any further. The goal is to end up with the smallest core components that are as tiny as possible. And by building and combining those tiny things, that's how we build the actual high-level thing. Then the step 3, this one is going to be a high-level overview on how to solve each core component. So for the health amount, we need some kind of variable to store some kind of hit point data. Then damage and heal, those are probably going to be functions. We might again have the concept of a minimum and maximum health. Now step 3, this one is really just high level. So this is meant to be pseudocode. It is not meant to be actual C# implementation. There's no syntax here. This is still just high level. And then finally, we do have step 4, and this is when we actually write the implementation details. So this is when we actually define, for example, hit points that should be stored in an int variable. This is how we define that the damage function should return void and should have parameters for the health amount. So step 4, this is very much where you actually write some code. Basically, step 1 is when we identify the problem. We start from a very high-level idea on what exactly we're trying to do, and then slowly, bit by bit, step by step, we break it down into its tiny core components, and then eventually implement those tiny core components. And by doing that process step by step, by doing that, we end up going from an idea into something that actually works. Again, like I said, in this lecture, I'm very much just covering the theory for this. But don't worry, the next lecture is extremely practical, and we're going to actually see how to apply all these steps to an actual practical purpose. Then the other problem-solving framework is the technical problem-solving one, meaning how to solve bugs, how to solve behavior issues, or really just things not behaving correctly in your games or any kind of mechanic you're trying to build. So for this, we have 3 steps. So step 1 is to identify the problem. For example, let's say we have a health system and bullets are actually healing instead of dealing damage. That's a problem. And over here, first we identified that problem. So we see, oh, the bullet is shooting the enemy, but instead of taking away damage, it's actually healing it. That's a problem. Then we have to actually locate the problem. So this is where we actually go into the code and we identify where exactly the problem lies, where is the exact line of code where something is going wrong. And to achieve this step, we actually have 2 possible options. So option 1 is to use debug.log. So this basically logs a message to the console. For example, you can add a log to see if this function, if this code is being run pretty much at all. Then you can add another log to see the health amount at various points. So this is one option to locate the problem. And the other option, the second option, is basically to just use the debugger. You can attach the debugger into Unity by using this button in Visual Studio. Then you can add some breakpoints in your code, like for example here. And then basically as you run your code within Unity, as soon as it gets to this piece of code, it's basically going to stop automatically. And now here you can inspect all kinds of variables, you can see what the code is doing, and you can even step into it, step out of the functions, you can go through the code step by step. Basically either one of these 2 options is perfectly fine. Either one of these 2 will allow you to basically inspect the code as it is running. So for these 2 options, use whatever option you prefer. If you like the debugger, go ahead, use debugger. If you like using logs, then go ahead, use logs. Now personally, I prefer logs, just because I'm already extremely used to using logging. It's how I learned how to debug 20 years ago when I first started programming, and I really just continued doing it ever since. So in the problem solving lectures, in the walkthroughs where I actually solve the problems, in those I am using debug.log. But if you prefer debugger, that's perfectly fine. Like I said, both options work fine, so use whatever option you prefer. When it comes to this, it is really very much personal preference. So do whatever you need to do in order to actually locate the problem, and then step 3 is to actually fix the problem. Now this is going to depend on what exactly the problem is. Maybe it's some kind of syntax error and you just change some code. Maybe it's some behavior thing where something is counting down instead of counting up. Maybe it's some kind of if that has the wrong condition attached. Basically every single problem is going to have a different fix. But over here, once we have located the problem, we can really just apply the fix to whatever issue is having. So by following these 3 steps, we can figure out how to find and fix pretty much any problem. First, you identify what exactly is going on, then you locate where exactly that problem happens in the code, and then you actually fix it using whatever fix that problem requires. And yep, so this makes my 2 problem-solving frameworks. By using these 2 on various types of problems, you will be able to solve literally any problem you come across. If it's a design thing, then you use this framework. If it's a technical bug, then you use this framework. All these simple steps, these can be applied to literally any problem you find, and by applying these, you will be able to solve literally any problem you come across. We will be using both these frameworks over and over again throughout this course. So by the time you reach the end of this course, by the time you do all over 200 exercises, by then you will definitely have this more than memorized. You won't need to actually get back and always try to remember all the steps. If you do all of that, then really this just becomes second nature to you. So yep, like I said, this is a very prevalent course. So now that we've heard the high-level overview, the high-level theory for these 2 frameworks, now let's actually apply them. So let's start doing that in the next lecture. Hello and welcome, I'm your Code Monkey. Alright, so here let's see how this course is structured. There are various types of lectures that each teach a different type of problem solving. This is a very practical course, so a very core part of it is in the companion project. In a future lecture, you can download the Unity project and just open it. This is basically where you will find all the practical problems for you to solve one by one. There are basically 2 types of lectures related to 2 types of problems over here on the companion project. So first of all, there are design problem solving lectures. So that's usually the first 2 lectures of every section. Basically, this is where we'll solve the problem of building all these various systems. So for example, thinking from a high-level overview, what exactly is a health system? What are the various things that we need to build to make a health system? What are the various things that we can break down into all of its core components? That is the first type of problem solving. Learning the skill of design problem solving, starting from an idea and going step by step until we have some actionable things that we can do. And the other lecture type is the technical problem solving. So for this, these are the over 200 problems that exist over here in the companion project that are related to the 15 scenarios that I have hand built myself. These are very much bite-sized problems that you are meant to solve. Some are errors, some are behavior problems, some are UI issues or random bugs. And of course, each problem has a walkthrough lecture where I solve the problem myself and I talk about how I go through solving it step by step. Now in those walkthrough lectures, I also make sure to tell you when to pause the video. You should absolutely take this. You should absolutely pause the video when I say and actually attempt to do the things that I'm saying. Like I said in the intro to this course, you will only gain the skill if you actively try to apply what you're learning. If you really just watch the videos, you won't really learn too much. Problem solving is very much only gained through experience. So you do have to apply all of this in order to make sure to gain this super valuable skill. So you should both try to solve the problems by yourself, and you should watch the videos just to hear me talk about how I go through and how I solve each problem. Now the third type of lecture, those are the high-level overviews. So the goal with these is for you to gain quite a bit more practice in the design problem solving. So we're going to break down a bunch of famous programs or websites and see how we could build them step by step. We're going to see, for example, how we could build something like Twitter, something like Steam, Discord, and so on. Now these are not meant to be technical lectures. There's really not much code in these. There's really no specific implementation. So the goal of this is really just to break down a problem. So start from a very high level overview and then break down step by step until we have the core components. And then technically you could take those core components and actually implement them yourself. The goal is really just to learn how to break a problem down. So by applying the problem solving framework to these various programs, you will basically learn the skill of high level problem solving, which you can then apply to your own projects. So anytime you have some kind of idea, you know how to take that process going from idea and break it down until you have step by step and you can actually implement those things. And then in terms of ordering, like I said, this is not a normal course where you go through it lecture by lecture, step by step. Although you can do that if you want. You can really just start from the finish, go until the end, straight up. That works. But you can also jump around if you want. Both approaches are valid. The only ones you should absolutely watch are the first two. So watch the first section step by step, and then jump into the simplest problem scenario, the health system. Make sure you watch the design problem solving lectures, and then at least a bunch of the technical problems. However, after that, it's very much up to you. If you want, you can just keep going lecture by lecture and do every single problem in the health system, then jump into the next scenario, do every single problem on those. You can do that. Or if you prefer, you can just solve about 8 or 10 problems, then move on to the next scenario, then do a bunch more, move on to the next one, and so on. So technically for each scenario, you don't necessarily need to do 100% completion before jumping into the next one. But still, I would definitely recommend that if you do take that approach, then basically in the end of the course, you go back and go and do all the problems that you haven't solved. And then there's also no ordering for the high-level design lectures. So for these, you can, for example, start going through this section right after the health system section. You can do all of these and then go back up to do all the other scenarios. So yep, it's really up to you how you want to go through this course. If you're not sure, then really just take it step by step from start to finish. Alright, so let's move on to the next lecture and start learning about problem solving frameworks. Hello and welcome, I'm your Code Monkey. Alright, so here let's do a quick overview of the companion project, how to install it, and see how it works. So first of all, you download the companion project from this page right here. Here it is, a nice zip file, so just download it. Then you end up with this nice zip file. So you can just go ahead and extract the file somewhere. So inside the file, if you open it, inside you can see how this contains an entire Unity project. So you just unpack this into a folder. For example, just up here, extract into this folder right here. And then you open up your Unity hub. Then you go into Add Project, add the project from disk. And over here, you select the folder that you just unpacked. So just do that and open it. And then the project will show up over here in your list. Then over here on the right side, if you don't have this version installed, if so, then you won't see a button to install it. Go ahead and install the exact same version. Then just click on it to open it. And yep, so here is the project. You can find all details on that over here on the project files, but mostly you'll be interacting with a bunch of custom windows. So up here, if you up top, you can see a menu saying Code Monkey. And over here inside this one, we've got 3 nice windows. So you can go into the Code Monkey main window. And if this pops out this nice window, so this is the main window that manages everything in this course. You can go ahead and dock this somewhere, like over here. This has a nice message, then a reminder of how you can join the private Discord and the weekly private live streams. And then of course you've got the lecture list. So here are all the lectures in this course. Each of these represents a different scenario. For example, here is the health system, capable of storing health, dealing damage, and healing. And then over here we've got a button to open up the exercises. And yep, out pops out the exercise window. I also like to dock this one over here on the right side. And here are all the exercises related to this particular scenario, the health system. So what you should do is you go through all the videos. And for example, let's say you're going through this video, the 1002 bullets healing. So you go through that one, and to complete that one, when I tell you to pause, you simply open up the companion project, then go over here on the health system, and on the right side, in this case, here we have exercise 02 on the health system, so you can open up this one, and here you just click on start exercise, and as soon as you do, it's basically going to unpack a bunch of files over here on the project files. It automatically loads the scene with the project, then just wait for it to compile once, and oh yep, here is the problem. So now you can hit on play, and you can follow the 3-step problem solving framework. So in this particular example, the bullet should damage the enemy, but if I click, shoots a bullet, and it's dealing healing instead of dealing damage. So if this is the issue that you should identify and then locate and then fix. Once you're done with that, once you've managed to find the issue over here in all of these scripts, once you've found the issue and fixed it, once you've done that, then you can go ahead and complete the exercise. But before that, if you get stuck, remember how over here you've got a hint and you've got a solution. So if you try to figure out the issue but you can't really find it, if so, then first go up here, go into the hint, and this will give you a hint as to what might be going wrong. Then based on this hint, try to solve it again. Always remember how this course is very practical. The only way you gain this skill is by actually putting in the effort. So that's why I'm saying take every advantage you can of actually doing it. If you basically just look at the solution right away, you're really just cheating yourself. So I really recommend you don't do that. I really recommend you taking the time and actually try to solve it. So try to do that based on the hint. Then if you are really stuck, you can go back, watch the video, and in the video I'm going to be talking step by step how I'm going to solve that problem. And if you get really stuck, then you can just click on show solution in order to see the solution for that problem. Then when you're done with finishing that problem, you can stop playing, you can click on complete exercise, and that is basically going to remove and clean up everything on the project files. And then yep, back over here on the exercise list, so then you can go to the next one, start the next one, and so on. So if you've got all that, and over here on the main menu, you can see the nice little counter showing all the exercises that have been done and all of the total ones. So ideally, by the end of this course, you should have 100% completed. Then on the lecture list over here, you can also see how many of each you have already done. Again, you should end up by doing all of them by the end of this course. And then the other very special thing that is included over here in the companion project that is one of the better bonuses of this course is over here you can go into CodeMonkey and open up the live chat window. And yep, like it says, this is a live chat window. So through this window, you can send messages directly to me, and you can see when I'm online or offline. Like it says here, this is generally me, this is not an AI. So I will try to be online as much as I can be. And over here, you can ask me any question. Like I have an issue with problem 1005. I don't know what to do. You can just say that, and then I will do my best to help. So yep, this is the nice companion project. It is very easy to use, and over here you've got over 200 exercises for you to solve. And I really hope you'll solve all of them. That is how you will gain this insanely valuable skill. So yep, now that you know how this works, let's go ahead and start solving some problems. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to see a quick overview of everything we're going to learn in this course. Okay, so we already saw the 2 intro lectures covering exactly what is problem solving. We learned what makes it the most valuable skill, as well as the 2 problem solving frameworks. Then we also download the companion project files. This is what we're going to use to make all the practical problems in the course. And now we're going to go into the various scenarios that exist inside the course. Now for these, they are partly standalone in that each scenario is basically self-contained, but at the same time, these later scenarios, they use systems that were built in previous scenarios. So basically, for example, the quest system, I'm pretty sure this one uses the interaction system and the health system. So it's easier to understand those. It helps. Basically, you've gone through the previous one before. First up, we have the health system scenario. So here we basically create a simple health system. So the unit has some kind of health. It reacts to changes, so we can deal damage, we can heal. It's really something very simple. So the health has a minimum and a maximum. So yep, something very basic to start with. Then we have the movement system. So this, again, another very simple movement system. We just use the WAS and these keys in order to move. We can move the character in basically any direction. The character has collision, so we cannot go through solid walls, and we can interact with other various objects. So in this case, we've got a bunch of panels in the world. Then we're going to work on an inventory system. So in this one, we've got a character we can control, and there are a bunch of items placed in the world. We have a nice inventory, and we can approach, and as we touch those items, yep, we add them to the inventory. So we can pick up a bunch of them, and then of course, we can drop items and remove items from the inventory. So over here, if I press on F, yep, there I go, basically drops the last item. So I can pick them up, I can drop them, yep. I've got a nice simple inventory system. The next scenario is the crafting system. So this one basically builds upon the inventory system. So we've got a nice inventory with all kinds of items. And then we've got a bunch of nice recipes. So in this case, for example, turning 3 gold ores into 1 gold ingot. So basically just to find a bunch of recipes, and then we can basically take an inventory as the input and output and convert those input items into the output items. So if I click on this, yep, there you go, I take 3 of those ores into 1 gold ingot. And of course, if I click and I don't have the items, then nothing happens. But yep, I've got various recipes I can do. I can add some more items to the inventory, craft more items, and yep, there you go, a nice simple inventory system. Then we have the enemy AI scenario. So the enemy has a basic simple state machine for defining some basic behavior. So in this case, the enemy basically starts idling, starts moving in one certain direction. Then it starts checking, is the player within range? And when it is within range, basically approaches the player, and then eventually starts attacking, starts shooting some bullets. So yep, it's an example of a simple state machine, but despite being simple, it's actually something that can be pretty complex. Honestly, most of the state machines, most of the AI that I've written for my games is really based upon this very simple concept. So despite being simple, this is very powerful. After that, we have the key door system. So this is really just like many systems that exist in many games. We've got a bunch of keys. So in this case, they are separated by color. So over here, I've got a bunch of doors. And if I approach them, then nothing happens because I don't have the key. These are solid objects, so I cannot go through them. But over there, I've got a nice inventory. So I can go ahead, I can pick up the blue key, and if I approach the red door, then obviously nothing happens. But if I approach the blue door, yep, there I go, basically consumes the key, opens the door, and now I can go through. And same thing for the red door. So basically the matching colors, those open up the matching doors. And if there you go, everything works nice. The next scenario is the gathering system. So on this one, I've got a player character I can move, and there are a bunch of objects in the world. So these are resource nodes. So I've got one that drops a bunch of gold and one that drops a bunch of wood. And I've got a nice equipment that I can use. I can move around, and if I press on F, I can either start or stop gathering. If I'm not gathering and I approach the items, then obviously nothing happens. But if I am nearby and I start gathering, yep, there you go, it starts dropping some items. So in this case, I'm gathering some gold ores. And if I approach this wood, there you go, starts spawning some wood, and I can pick it up. And over there, I see a nice inventory containing all my amounts. So yep, this is just like a gathering system that you can see in so many games. Basically, any game that uses any kind of resource gathering, basically is going to use some version of this system. Then we've got a pretty fun one, so this is the safe system. This one is very much based on the same demo for the gathering system. So over here, I can move around and I can gather items. So yep, there you go, exactly as intended. However, then this is the safe system. So over there I can see, so I can basically touch the items to pick them up. So I currently have 2 gold ores and 0 wood. And if I press on T, I can see on the console, yep, there you go, I've saved my data. And I can stop playing and I can start playing again. And now if I press on Y, and if there you go, basically reloads the exact save. So that item ore was over there and over there. And I had 2, 0. Yep, there you go, everything loaded correctly. So you have a nice safe system. And again, as with all these other systems, you can take this as a base and then build upon it. So this is the most simple version of a safe system, but you can easily just add more things onto it in order to save basically literally any data you want. Next up, we have the interaction system. So this is another very common one that so many games use. So in this case, I've got a player here that I can move around, and there are 2 objects in the world. So one of them is an NPC and one of them is a weapon. And importantly, these both work with the interaction system. However, they are completely different, so they each have different interactions. So for example, over here on the NPC, first of all, I need to approach in order to be able to interact. I can't interact if I'm way too far, so I need to be close enough. And if I'm close enough, I can see the little prompt. And if I press on it, yeah, there you go, I can interact with this object. And over here, this one, this NPC really just talks to me. So that's the specific interaction that I made. But again, the interaction system can work with literally any interaction you want. So on the other side, over here, I've got a nice pistol. And if I approach and I press on E, yep, this one basically the interaction is essentially picking up that weapon. So I can pick it up, now I can carry it around, I can go here, I can talk to this one NPC, and if there I go, basically a really nice interaction system where each interaction can be very unique. After that, here we have the quest system scenario. Honestly, this is one of my favorite ones. This is one of the ones that I most enjoyed building just because of how I structured the code. I really enjoyed making this. So here, this is a quest system, and it's also combined with both the inventory system and the interaction system. So I can see over here, I've got 2 NPCs with quests, and they are working with the interaction system, so I can approach them in order to interact. So if I go ahead and I press on E, there you go, I can see a quest has been added to the list. So I've got this quest that is currently active, get 5 apples, and I can see there I'm currently at 0%, and over here I can see a bunch of apples. So I can go and I can touch them, and there you go, I picked up that apple and I gained some progress, and I can go 24%, so I picked up 3 apples, now 4, 5, and there you go, complete that quest. And this other quest, this is also a different quest, because again, each quest is obviously going to be very different. Each of them is going to have different completion conditions. So that is what I mean when I say that the structure for this code is very nice, very clever. So here in this case, this one is 150 meters, so I can really just walk around. And there you go, after I walk for a little bit, I can basically complete this quest. And if there you go, really nice modular system. Then we have the equipment system. So yet another thing that so many games use. And here, basically I've got my player character, and I've got 2 different equipments I can use. So I've got this one, simple bow, so I can click in order to aim and shoot some arrows, that's it. And then I can press on 2 in order to equip the other equipment. So in this case, I'm equipping some kind of pickaxe. And this one is basically using the same gathering system that we saw previously. So I can go to any of these, I can click in order to start gathering. And there you go, I can now pick up a bunch of gold ore, or I can pick up a bunch of wood. And as soon as I'm done, I can go back into the bow, fire the bow, and yep, there I go. So once again, everything's very unique. So I can have literally any kind of equipment I want. Each of them with completely different interactions, completely different logic. And everything works fine with the equipment system. I can equip any of them and everything works nice. Next up, we have the building system. So this is a little bit more of a complex one. Again, this one also reuses a lot of systems that we built previously in the course. So it uses the inventory system, it uses the interaction system, and a bunch more. So over here, first of all, I can click on F in order to select the hammer blueprint. And there are 2 buildings I can build, either a house or a fire pit. So I can build, let's say, a fire pit. And there you go, it basically spawns a blueprint in the world. But the building is not yet built, that is really just a blueprint. So now I need to go ahead and I need to gather some items. So if I press on E, I can interact with it and I can see, okay, so this one, in order to construct, it requires 3 wood. So let's go ahead, pick up a bunch of wood, then go near the building and let's add some resource onto the blueprint. And now that the resources have been added to the blueprint, I can just start swinging my hammer. There you go, it starts adding progress. And when the progress is complete, there you go, the building is fully finished. And now in this case, this particular building has logic. Some buildings may have logic and some may not have logic. This one does have logic, so I can interact with it. Again, the same interaction system. In this case, I can add wood onto it. And over there on the inventory, I still have a bunch of wood, so I can add some wood onto it. And there you go, in this particular building, basically just burns the wood to generate some nice heat. So there you go, that's this building. And of course, I can spawn the other buildings, so I can spawn a house. And this one takes a bit more, 5 wood, 5 stone. So I can equip a bunch of this. I can pick up the resources. I can add them over there onto the blueprint, add them all. Then start swinging in order to start adding some progress. And this one takes a little bit more to build. After the whole thing is built, there you go, the house is fully built. And this one, like I said, this one is really just an object that exists in the world. So it doesn't have any logic, so this one doesn't do anything. It's just an object that's built. And over here, the fire pit, yep, this one does have some extra logic. So yep, a really nice building system. Then we have the need system. So this is another very common one, especially for survival games. So I've got a hunger and a water bar. And there you go, as they go down under 0, I start taking damage. And I've got some items, and I can equip those items. And there you go, I can basically consume a bunch of water, consume a bunch of food. And as I do, basically increase the hunger or the thirst. And if those goes above, then I'm no longer taking damage. So I can eat, I can consume, I can even craft things in order to create some items that generate a bunch more. And there you go, so basically needs go down, I take damage, I can consume to bring them back up, and that's really it. Again, something that is very crucial to pretty much literally any kind of survival game, any of those is going to have a system just like this. And then we have the farming system. So this is another very common one, especially for games that are like colony building, village building, and so on. Something like Stardew Valley, those games usually always have some kind of farming system. So in this case, I designed it the way that there's some kind of land plot. And this one again, this one is also using the interaction system. So I can approach with it in order to bring up a window. And here it tells me to select seeds, but I currently don't have any. So this works with the inventory system. I can pick up a bunch of these seeds and I can go there. And there you go. Now I can plant some seeds. So this one plants some apples and this one bananas. So let's plant some apples. There you go. The apple seed is in there and I can see. Now in order for this to grow, obviously it needs some water. So I can go ahead, I can pick up some water and I can press a button to add water. And of course, now the plant is basically going to be consuming water and growing. Then if I add enough water, it basically goes from stage to stage, and each stage has a different visual. And if I keep adding a bunch of water, if so, go through all the stages, so stage 1, and then afterwards, yep, there you go, now it is fully built. So now I can basically harvest the tree, and there you go, now this one drops a bunch of stuff, so it dropped some nice seeds and some nice apples. So now the land plot is back to standard. I can add a bunch more stuff, I can pick up some more water. I can go ahead, water the crops once again, the stages go up. And when they go fully up, they get fully grown. I can harvest again, and there you go, drops the full items and anything I want. So yep, another really awesome farming system, another thing that you can see being used in pretty much any kind of game. So yep, those are the scenarios included in the course. As you can see, quite a lot of them, ranging from super simple to quite a bit more complex. And all of them, of course, all of them with a ton of exercise for you to solve. So yep, that's everything we're going to cover throughout this entire course. Now let's go ahead and get started with the health system in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to design a health system. So let's learn how to make a health system, or more importantly, let's learn how to solve this problem, how to think of all the steps we need to take to go from a basic idea, health system, and make it into something that actually exists. In this lecture over here, we're going to be doing both step 1 and step 2 of our design problem solving framework. So first of all, we need to actually identify the problem. So what exactly is a health system? There's lots of games that have health systems and they can be implemented in many different ways. But in general, it's really just a way of representing some kind of health, some kind of mana, some kind of energy, something like that that exists in-game. And that's really it. It's a very simple idea. So this step 1, identify the problem. This is very simple. Then step 2, now this is the really crucial one, which is break the problem down into core components. So basically, let's think of all the things that our health system needs to be able to do. What could we possibly need to do with it? What does our game need to do with the health system? I want you to think about that answer. Think about what exactly does the health system need. Go ahead and break this problem down into all of its core components. If you want, you can open up Paint, you can pick up a pen and paper, you can pick up Notepad, really whatever you want. Anything that helps you take that from an idea and actually start to break down into various pieces. Think about what data does it need, what behaviors does it need. It doesn't need to be complex. In fact, it should not be complex. Really just focus on breaking that down into its core components and nothing else. Break it down into the simplest components you can. So yeah, pause the video right now and go do that. Okay, so for a health system, so let's do step 2 of our problem solving framework. Let's break it down into its core components. We want it to represent some kind of health amount or energy. And to do that, we need to be able to store something for the health amount. Then it should be able to go down when taking damage, or it should be able to go up when healing. Then it should also have some kind of maximum and minimum. So for the most part, this is really what you need in order to make a very basic health system. we need to store some kind of health amount so we know the current amount. Then we should be able to manipulate it in various ways, like for example, make it go down when taking damage, make it go up when healing. And if we make it go down, go up, at some point we should have some kind of maximum and some kind of minimum. So if this is really all the basic things that we need for a health system, we can define how much health something has, we can deal damage, we can heal, and we can stay within a valid range. Now, like I said, this is the most basic, which is exactly what you should be doing in this step of the problem-solving framework. You should figure out the most basic iteration of the system you are trying to build. Of course, we can add tons of things on top of this. For example, we could add some kind of mechanic that adds auto-healing after some time. We could add, for example, stackable systems, so we could have like a health amount and some kind of armor amount. And then when dealing damage, first it consumes the armor and then the health. So there's lots of things that we could add on top of this basic design. But like I said, this right here is a very crucial part for how to solve any problem. First, solve the most basic version of the problem you're trying to solve. And then later on, if you want to, then you can expand upon it further. But first, always start by solving the most simple version possible. And when it comes to health system, I really don't think we can go any simpler than this. We've got an amount, we go down or we go up, we have maximum and a minimum. That's really it. That's the most basic interpretation of a health system that I can come up with. Another crucial part about over here about step 2 is how you should break it down into its core components. And how exactly do you know what are the core components? The answer is basically when you can't break it down any further. So here these are all very simple. Store a health amount. You can't really break it down into anything more simple than that. It's just a simple value. Same thing for dealing damage. You can't really break that down into anything more. So once you cannot break these down into any more simple core components, then you have definitely reached a point. Whereas if, for example, let's say we want to implement some kind of lifesteal mechanic. If so, then over here we would not have add a lifesteal effect. We would not do this because lifesteal, that's not really a core component. It is not because we can actually break this down into its core components. We can break this down further, which means it is not a core component. Lifesteal means two things. It means dealing damage to the enemy and healing the player. So if we want to implement this, some kind of lifesteal mechanic, if so, then we really should be splitting it into these two things. It should be able to take damage and heal. And if we combine those two into one thing, that is how we actually have a lifesteal effect. But since we can't break this down further, then this should not be here. We should focus just on the core components, and then we can use those core components to build more advanced mechanics on top of it. So during this step, that's a crucial part. Make sure you focus on just identifying all of the individual tiny core components. And if you don't know what those are, keep breaking it down until you get to the point where you can't break it down further. So this is really where we stop in terms of identifying what exactly is our health system. Here we did step 1 and step 2, so I identified the problem, what exactly is the health system, and we broke that problem down into its core components. We have those core components right here. If we implement all of these core components, we will solve our underlying problem of building a health system. So now we can start to think on the next step. Let's start to think of a high-level overview on how we could technically implement this. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to take our health system problem and we're going to start to think of a high-level implementation. Okay, so here is the high-level overview on what exactly is a health system that we created in the previous lecture. So first of all, in general, what it is, it's something to represent some kind of health amount or energy. And the things that it needs to do, the core components of it, are basically we need some way of storing a health amount. We need it to go down when taking damage, go up when healing. And since we have those two, we should have some kind of maximum and some kind of minimum. So yep, these are the 4 core components to making a health system. And now we can basically solve these one by one. So we're going to be making over here step 3 and step 4 of our problem-solving design framework. First, let's think about a high-level overview on how to solve each of these core components. Now, the important thing over here on step 3 is we are only thinking of a high-level overview, meaning right now we just want to come up with some high-level pseudocode on how to potentially implement these features. But importantly, it is not meant to be valid syntax, it is meant to be pseudocode. Only when we get to step 4, only then do we actually write proper C# code. So yep, let's solve this third step. So based on these core components, let's figure out how do we create a high-level overview in code of these. So just think about what data do you need, how do you store that data, what data structure you might need, and what behavior, what if these things are meant to be functions, what should those do inside of it. Like I said, right now, don't worry about the internals, don't worry about C# syntax, just think in pseudocode, just think about a rough blueprint that we will later on implement in proper code. So yeah, pause the video right now and do that. Okay, great, so let's think of a high-level overview, high-level implementation of this system. So first of all, our system needs to be able to store some kind of health amount, and health amount is really just a value, so we're going to have some kind of variable, and name it something like health amount. Then for these two options, for dealing damage and healing, this is some kind of behavior. So for this, it will be some kind of function. So we're going to have some kind of damage function, and this one will lower the health amount. And we're going to have another function, some kind of heal function, and this will increase the health amount. Then for implementing the last core component, it should have a maximum and minimum. So we should implement the concept of a maximum and minimum over here in these two functions. So damage function, this one will lower the health amount, but then of course, test if under minimum, and then over here on the healing function, so this one will increase the health amount, and then test if above maximum. And then for defining that minimum and maximum, so minimum should probably be 0. We can technically make it whatever we want, but in this case, let's go with something simple. Let's go with just 0. And then for the maximum, this should be perhaps defined in a variable. So for the most part, this is it. So we took what we had, which was a very high level of review of just the core concept, just the ideas that make up a health system. And now we took it just one step further, and we started thinking more in terms of logic, more in terms of programming, but still not exactly just syntax. So in that, we come up with an idea of how we should have some kind of variable to store the health amount. We have some kind of damage function that needs to do a bunch of things. Same thing for the healing function. This one should also do a bunch of things. And then how we define minimum, maximum, and so on. So yep, with this over here, we have solved step 3 of our problem-solving framework. We have successfully created the high-level overview on how to solve each of those components. And now it's time for step 4, which is the actual implementation details. So this is where we actually start writing some proper valid C# code. So for that, let's open up here the companion project. Let's go on the lecture list for the health system. And over here on the exercise, make sure you open up this exercise, this scenario, the one that says to do. Here's where we're going to implement our health system following the guided path that we've prepared. So by default on this scenario, it already has a health system script. So let's go ahead, double click on this. Here it is. It's a completely empty thing. So plenty of space for us to write our custom implementation. Now let's take our design here and write it into actual C# code. So first of all, we need some kind of variable for the health amount. So over here, let's define that. And when it comes to a health amount, over here, we have an interesting question we need to ask ourselves, an interesting programming question. Here, basically, we have two options. We can make it either an int or a float. And both those options are perfectly valid. This is definitely one of those game design questions. There's really no right or wrong answer. It depends on what exactly you want, what exactly you're trying to do. Some games do want to have decimals in their health, whereas other games are perfectly fine with just whole numbers. So if in this case, anything can work, it's really up to you to define. Over here, let's keep it simple and let's do it just ints. So let's make it private int and call it a health amount. Okay, yep, so there we have our nice variable. This is where we're going to store the health amount. And then based on our design, we want to have some kind of function to deal damage. And then we're also going to have some kind of function to heal damage. So let's make a private void damage. And by the way, start off by making everything private by default. And then we think about what exactly do we need to expose to other classes. But first, let's make it private. So private void damage and private void heal. So we've got these two functions. And now based on our design here, so damage function, that one should lower the health amount and should test under the minimum. This one should increase and test above maximum. So over here for damage, let's count down the health amount by something. And now here's an interesting question, which is as we are implementing these, try to think about, could you perhaps need some sort of extra data for this? For example, in the case of damage and healing, we could do this and for example, just go, in this case, health amount minus minus. So just reduce the health amount by 1. And over here for the heal, health amount plus plus. We could do this. This is valid code, but it is a little bit too limiting. We're really just counting down damage by 1 or healing by 1. We really don't have too much variation as to what we can do with it. Now, for some games, this can be fun. Like I said, this is another game design question. If in your game, you always heal just by 1 unit and always damage by just 1 unit, if so, then this implementation would be perfectly fine. But in this case, I want to make it a little bit more adaptable. So if you want, go ahead, pause the video and try to figure out how would you write this code in order to make it a bit more adaptable so it doesn't force you to just use 1 damage or 1 heal. So yep, over here it's pretty simple. When thinking about what other extra data do we might need for these functions, really just over here some kind of int for some kind of damage amount. And then instead of decreasing by 1, decrease by the damage amount itself. And over here an int for the heal amount. And then really just plus equals by this heal amount. Okay, yep, now like this, our code is a little bit more adaptable. We can deal different amounts of damage or heal different amounts. And then back to our design, we need to test if we are under the minimum or if above the maximum. And for our definitions here, so the minimum should be 0 and maximum should be defined in some kind of variable. So for the minimum, we can just check if the health amount, if this one is under 0. If so, then let's just set it to 0. So health amount equals 0. And then this one, if it's above some kind of maximum, and let's store that maximum over here in a variable. So private int, health amount max. We define this, and over here, if the health amount, if that one is above the maximum, if so, then health amount equals the health amount max. Okay, yep, just like this, very simple code. So yep, just like this, we have basically implemented the design that we wanted. We have a health amount, we have a damage function that does everything it's meant to do, we have a heal function that does what it's meant to do, we have defined the minimum, we have defined the maximum. So step by step, we took our ideas, starting from a concept health system, and breaking it down bit by bit. Until now, we actually have some code that actually works. But another crucial part about solving pretty much any kind of problem is always remember problems are not really fixed, they are meant to be adaptable. Specifically in terms of programming, that means refactoring is a perfectly normal part of the process. So let's say, for example, okay, we come up with this design, and this is the first thing that we start to implement. But now we think perhaps we could want some more things. Let's say some more simple things. Let's say we should have some kind of function to test, is this health system dead or not? Now we didn't come up with that over here on the original design, but like I said, that's fine. The design is not meant to be stuck in stone. It is meant to be something that is adaptable, that you can refactor to add or move things whenever needed. So for example, over here we can think about what questions do we need to ask the health system. We might want to ask, is this health system dead or not? So we might have something that returns bool called is dead, and over here we just return if the health amount is under 0. If so, then yep, this enemy is dead. Then we could also ask some kind of bool is max health. We could ask this, and we would return the health amount is bigger than the health amount max. So yep, the crucial part is, like I said, it is not meant to be fixed in stone. So as you're doing all these steps of taking something from an idea into reality, you go through it step by step, but always remember it is not set in stone. You can refactor, you can add things after the fact. Okay, so let's say like this is the health system exactly as we want it. So we've got the health amount max, we can damage, heal, and ask some questions. Now of course, let's write some proper code, some proper C# code, and following some good clean code guidelines. For example, in terms of access, right now everything is private, so right now this class isn't really usable. So let's think about what can we or what should we expose to other classes. And for the most part, other classes should be able to damage, should be able to heal, so this should actually be public. Same thing for the heal, other classes should be able to heal. And then asking these questions, yep, other classes should be able to ask this. However, for this data, for the internal data, this really should only belong to this class. Other classes should not be able to directly modify the health amount. So these over here should remain as private. And finally, in order to make this health system easy to use, in order for that, over here for the health amount, we don't want to expose it. We don't want this to be public, but we do want it to be editable in the editor so we can easily customize it. So over here, we can add a serialized field. That way it's editable in the editor. So let's do it for both the health amount and the health amount max. And now if we go back into our code, now if we look over here inside the enemy, and yep, the enemy does have the health system, and yep, it does expose the health amount and the health amount max. So over here, let's say this enemy starts off with 100 health and 100 health amount max. Okay, so here we have a nice health system. This works perfectly fine. We can connect it to the rest of this demo to see it in action. So over here on this demo, I can click to shoot, and that's over here on the scenario script. So this one tests for a left mouse button and just spawns a bolt prefab. And then the bolt prefab is this prefab right here, which has the bolt script. And then the script really just moves the bolt to the right side and checks for a collision. And if it collisions, then over here, it should deal damage to this enemy. So in this case, let's hook our logic onto our health system. So let's go on the enemy. Let's call get component of type health system. So the one that we just wrote. And then we call damage function that we just exposed. And let's say we want to deal 30 damage. So yep, just like this, in order to verify this is working, over here, let's print out the health amount. So debug.log, let's call damage. And let's print out the current health amount. Okay, so like this, let's test and see if our health system is working as intended. Okay, so here I am and let's shoot. And by the way, let's ignore the health bar. That one is not connected yet. So let's shoot and just look over here on the console. So as I click to shoot, and there you go, it does deal damage. And it currently has 70 health. So 100 minus 30 equals 70. Yep, there you go, it works as intended. Now click again, and there you go, goes down to 10. And now if I click, let's see if we did implement the minimum correctly. So if I click right now, it should hit, and there you go, it goes down to 0 as opposed to being in the negatives. All right, awesome. So yep, we have successfully implemented a nice health system. We started off as just a rough idea. We want to build a health system, still no idea what that is, but we just started with that. Then we did step 1 of the design problem solving framework. We first identified what exactly is a health system. And then we went into step 2 to break it down into its core components. So these are the core components that we defined. So it should store some health amount, go down when taking damage, go up when healing, have some kind of maximum and some kind of minimum. And with those core components, then we implement a high-level overview on how to solve each of those components. So we took that rough idea and made some nice sort of high-level implementation on how we could implement these. Again, just pseudocode for starts. And then we did step 4, we wrote the actual implementation details, the actual C# code. And that is how we ended up with this nice class right here, which works exactly as intended, follows exactly what we wanted, and does successfully achieve solving the problem of how exactly do we build a health system. We want to do that, and yep, over here we have it, over here, now it exists. So yep, by following these 4 simple steps, we were able to take something from a just basic idea and break down bit by bit until we have something actually implemented, something that actually runs some actual code. Now, like I said, importantly, let me once again remind you of something that I've already said many times that I will keep saying, which is when you are solving problems, specifically design problems, keep in mind these are not set in stone. So as you solve the most basic edition of your problem, if you want later on, you can absolutely refactor and modify the problem in order to suit your new needs. So as your requirements change, your code changes with it, that is perfectly fine. You are not expected to write perfect code the first time around. First you write just the basic amount of code, and then later on when you need some more, then you write a bit more, you expand upon it. But always for starters, when solving some kind of problem, always solve the most basic version of the problem first, and only later on adapt to whatever new requirements you have. In fact, let's do some refactoring right now. So over here now, this is working. But like we saw, the health bar over there, that one is not working. So let's go ahead and implement that nice health bar. So over here in the code, already pre-prepared the health bar script. But this one really just has a reference to a bar image, doesn't have any code. So over here, we want this health bar to be able to represent whatever the current health amount is on the health system. So we're going to need to get some data from the health system. So we should probably have some kind of serialized field for a health system for our health system. And let's make it a serialized field just so we can drag it in the editor. So over here in the script, let's wait for it to compile. Then let's go for the health bar down here. And this one does have the health bar component, which does have a field for the health system. So let's just drag the enemy object as a reference. There you go. And over here, let's go and update our health bar. So for that, let's make a function, update health bar. And on this one, we're going to go into the bar image. And over here for the bar image, I set it up as a bar. So here it is, just a simple image component. And importantly, I set it up like this, image type filled and filled from left to right. So basically we have this nice fill amount and we can modify this between 0 and 1 in order to show the state of the health bar. Meaning we really just need to convert our health amount into a normalized value between 0 and 1. So over here, we set the bar image.fill amount. We go in the health system and we need to get the health amount normalized. Which again, over here on the initial implementation, we did not implement that function, which like I said, refactoring a perfectly normal part of the process. So over here, now that we have new requirements, we need the health bar normalized. Because that, let's do that. So return a poly float for the get health amount normalized. And really just return the health amount divided by the health amount max. And over here, since we are working with ints, we need to make sure to convert at least one of these into a float in order to make sure we get the actual normalized value. Otherwise, we get a bug. By the way, it's actually one of the problems that we will see throughout this course. So if we have that, then over here, get the health amount normalized, and that will update the health bar. Then as to when we update it, let's do it on start. So as soon as we start the game, let's update the health bar. Then of course, we want to update whenever the health bar changes. So again, let's add some more features over here to our health system. We want to know when exactly does this take damage. So for that, let's make a nice event. So public event, make it of type event handler, just the usual C# standard, and call it on health amount changed. So we have this nice event, and over here on damage, when we have the damage function, let's invoke this event, put it with this event args.empty, and same thing on heal. When we heal, let's invoke that event. So now over here on the UI script, on start, let's just go on the health system and go onto that event. Let's hook onto it. And over here, whenever the health amount changes, let's just update the health bar like this. So yep, there you go. So over here, we have refactored some code. We add the new event and we add the new function. And now we should have a successful refactor and the health bar should be working. So over here, let's test. And yep, right away, we can see the health bar starts off as full. Now if I click and go, and there you go. Now it's 70% full. There you go, 0.7. Click again, goes down to 0. And yep, everything works. The console works. Everything is working perfectly. So yep, awesome. Once again, this is another very crucial thing. First, start off by solving the most basic version of the problem you're trying to solve. And then later on, when the requirements change, then you can refactor the code to support the new requirements. So yep, this was a very quick practical example of how refactoring is a perfectly normal part of the process. Do not be afraid of it. You first solve the simple version and then you refactor it. Okay, great. So over here, we solved this nice problem. How exactly do we make a health system? We followed our 4-step design problem solving framework and we started from a problem. We broke that problem down into the core components. We created a high-level overview on how we could solve each of those components, and then we wrote the actual C# implementation details that actually turned that rough idea into something that actually exists. By the way, very importantly, a quick mention. Over here, if on the exercise window, if you click on complete exercise, if you do that, it will delete your files. So over here for the project files, all of these won't be deleted as soon as you click on that button. So if you yourself created some kind of interesting implementation of the health system that you want to keep for future use, if so, then make sure you back up these files, back up your health system. You can back up this entire folder. Back that up outside of this folder so it doesn't get destroyed automatically. Because again, like it says here, when you complete this exercise, it won't delete all these files. So if you want that, if you want to keep your own health system implementation for future reference, if so, go ahead, make a backup before you complete this exercise. So yep, here we built a nice health system. Everything works. That's awesome. Now let's figure out how to solve a bunch of problems related to this health system. And let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. Alright, so here's a quick recap overview of the health system demo. As always, in order to solve any problem, first you need to know what exactly you're working with. Usually you're writing the code yourself, so you're already familiar with the codebase. But in this case, the scenarios that I've created for all the problems, those have a little bit of setup other than just the systems themselves. So let's see everything in this scenario so you know all the scripts involved in order to solve all the problems yourself. Okay, so here we have the scene 1001. That's the completed scenario for the health system. If we go ahead and play this, so up here there's a pistol, there's a zombie. The zombie has a health system, it has a health bar. And now as soon as I click, yep, there you go, the pistol shoots a bullet, the bullet moves forward, hits the enemy, deals damage, and we can see over there the damage amount. So yep, a nice simple demo to demonstrate the health system in action. Here are all the scripts in the demo, so we've got the bullet, we've got the enemy, the health bar, the health system, and just a general scenario script. So the health system over here, this is the one that we built. It stores basically a health amount, then we have functions to deal damage, functions to heal, to get the health amount and the health amount normalized, as well as checking if this health system is dead. Then importantly, there's a nice event, so this event is fired whenever the health amount changes. The health bar, this is the other important class. So this one contains fields for the health system that is going to be updating this health bar, and then it contains the bar image. Then over here, we really just listen to the health amount change event, and when that happens, just go into the bar image and set the fill amount to the health amount normalized. So over here in the editor, we can see how it's set up. So here we've got the health bar, and the health bar is over there, right on top of the zombie. And inside the health bar, we can see the inspector. Over here, it has the health bar script, which contains a reference to the health system. So that's the one that is attached to the enemy. So yep, there it is, the health system. Then on the health bar itself, over here on the bar, this one is set up with a white 1x1 pixel. The reason why it has that is just so we can access over here the image type. So then it's set to filled. It's filled horizontal, left to right, and over here is the fill amount. So that is the one that script is modifying. So over here, this one can basically fill the health bar, either make it full, make it empty, and this is a normalized value, so it goes between 0 and 1. So if that's the health bar, then we've got a script attached. So over here, the scenario script. This one contains a reference to the bullet prefab as well as a shoot point. And on update, really just checks if the left mouse button, if that one is pressed, and if so, really just spawns the bullet prefab on the shoot point position. We can see the shoot point position, that is a position stored over here next to the pistol. So this is the pistol sprite, and the shoot point is over there right at the muzzle of the pistol. So over here on this script, we've got a reference to that one, the shoot point, and we've got a reference to the bullet prefab. And then the bullet prefab itself, here it is. So it's just a simple bullet and has the nice bullet script. And over here on this script, really just tells to destroy after 3 seconds. This is just to make sure there's some cleanup so we don't end up with a ton of memory being wasted. Then on update, basically on every single frame, it's going to move straight right by this move speed. And then it's checking for collisions. And if it collides with something, it tries to check if that something does have the enemy component. If so, then goes inside the enemy, gets the health system component, and just deals damage and destroys the bullet. So finally, for the enemy script, so here it is. The game object has both a health system and the enemy script. And over here for the enemy script, it's really just an empty script. It was really just used as a tank component, just to identify it as the enemy. So over here, if I press the left mouse button, it spawns a bullet, hits the enemy, deals damage. So over here in the scenario, testing for the mouse. On mouse press, just spawn the bullet prefab. The bullet prefab has the bullet script attached to it. So over here, really just moves to the right. Then checks for collisions. Eventually it hits the enemy. Again, that is just an empty tech component. And since the enemy already has a health system component, just gets a component of that one, deals damage. So yep, over here on the health system, this one is going to deal damage. It is going to lower the health amount. It is going to fire off the event. And finally over here, the health bar, that one is listening to that event. And when that event happens, really just updates the health bar visual. So yep, we can click, we can shoot some bullets and deal damage to the zombie. Alright, yep, so this is how the health system scenario is set up. Now based on this scenario, let's start solving some problems. Hello and welcome, I'm your CodeMonkey. Alright, so in this lecture, let's solve a problem with our health system. Now, like I mentioned in the starting lecture, if you want, you can just pause the video right now and try going through the 3-step problem solving framework. So first, identify the problem, then locate the problem and fix the problem. You can try solving it yourself from scratch, or you can take it step by step and pause when I tell you to pause. On these first few lectures, I recommend the second approach just until you have a bit more experience at debugging, and then you can attempt the first approach, which is going to be quite a bit harder. Okay, so here let's solve the problem 1002, that is the bullets healing. So the problem here is that the bullets should damage the enemy, but if we play, over here the enemy has a certain amount of health, and as I click the bullets go, and if they go, instead of dealing damage, they're actually healing the enemy. Okay, so yep, so this is the problem we're trying to solve. The bullets should be damaging the enemy. So let's go over here through our 3-step framework. So step 1 is identifying the problem. That's what we just did. So we tested out our scene and we saw, yep, we have a problem. The bullet is meant to be dealing damage, but instead it's actually healing. So yep, we have identified the problem. So let's go to step 2. So let's actually locate the problem. So let's look at the code, try to figure out where exactly it's healing instead of dealing damage. Let's start off by opening the scenario script, so the bullets healing. And now, like I covered in the intro video, here we have basically two options. We can use either logging or debugging. Either method works. In my case, personally, I prefer logging, so that's what I'm going to be using. Or rather, first, like I said, I want you to try doing this yourself. So try to think about the step 2, try to locate the problem, add logs wherever you think they are needed in order to identify where exactly this problem might be happening. So this is basically the starting point. When we press the left mouse button, we're going to instantiate the bullet. Then the bullet is going to do something. It is going to try to cause damage. And somewhere along the line, it is going to be healing instead of dealing damage. So yep, go ahead, add a bunch of logs wherever you want. Like for example, right here, add a log just to verify the bullet it is spawning. Right, so go ahead, pause the video right now and do that. Okay, welcome back. So let's go ahead, add some logs at every step of the process in order to validate that the code is running like we think it is. So first, let's validate that the code path is working as intended. So first we left click, then we shoot a bullet, so we should be able to see this one. The shooting the bullet, that one is actually going to instantiate this bullet, and this bullet over here has the bullet script. So this bullet script, this one should be spawning the bullet, so debug.log, spawning bullet, let's make sure that one goes through. Then the update, the bullet should be moving right, which like we saw, it is indeed moving right, so we can be pretty sure that this line is indeed running. Then let's verify that the onTrigger enter2d, this one is working, so let's write a log on this one. Then let's verify that we are indeed finding the enemy. So here, found enemy. And then we're going to go inside the enemy, getting the health system component and calling the damage function. So we can let's do debug.log, let's call damage, and let's also pass in the damage amount. Okay, so yep, let's set all of these logs, let's save everything, and let's test. Okay, so looking at the console, pressing left mouse button, click, goes, shoots. And if we can see, so the shoot bullet, that one worked, spawning the bullet, that one worked. onTrigger in 2D, so the collision for the bullet down did work. It did find the enemy and did actually call damage. So here we have basically validated that the issue is not necessarily in the code path, meaning all the code appears to be running exactly as intended. We shot the bullet, it spawned, it found the collision, found the enemy, dealt damage to the health system. So you have now go ahead, add a bunch of logs within the code path in order to try to figure out where exactly things are adding health instead of removing it. So you have pause the video right now and do that. Okay, so let's continue. So using the logs, we were able to verify that this function over here, this one is being called. So over here, for example, let's test out the health amount. So let's do a debug.log, let's say the before health amount, and we can print the health amount, and then we can do our math, and then we can do the after health amount, and we can print that one. And technically we should be able to see a higher number and then afterwards a lower number. So yep, let's save and let's test. So here we are, click and shoot, and we've got the shooting, we've got the collisions, it found the enemy, it dealt damage on the health system, and then the before health amount was 50, but afterward was 60. So yep, right away here we do see the problem. Now this is an obvious one, so you probably already saw this one a while ago. So the problem is between this line and this one. So we have verified that the problem is somewhere within these two lines. So back to our framework, you can indeed check the step 2, we have located the problem. And now it's step 3, time to fix the problem. So now here, let's go ahead and fix it. And this one is super simple, so I'm not even going to tell you to pause. The answer is pretty obvious. In fact, in this case, you probably already figured out the issue a long time ago. The problem is very simple and very obvious. Over here, we're doing health amount plus equals the damage amount, when it should be doing minus equals. Here we have logged that the damage amount was a positive value. So over here on the logs, damage 10. So this is the amount that we should be subtracting, so it should be health amount minus equals damage amount. And now if we test, we should be able to see the before health amount and the after health amount, and these should be correct. So here we are, let's click, and goes, and yep, there you go, now it does deal damage, and we can see, yep, the logs, all of them worked. So we're calling damage with 10 amount, and before we had 50, and afterward we had 40. So 50 minus 10, 40, so yep, everything is correct. Alright, awesome! We can toggle our step 3, we have completely solved our problem. So yep, here we'll learn how to solve this nice, simple problem. The bullet was healing instead of dealing damage. We first identified the problem by playing the scenario. Then we added a bunch of logs in order to locate the problem. And finally, we applied the fix to this problem. In this particular case, just swapping plus equals with minus equals, and everything was nicely solved. So yep, this was a very simple problem to solve, a very simple exercise. But despite being very simple, we did go through all steps of our framework. And this is really just all we have to apply for any problem in any complexity. First, identify it, then locate it, and then fix it. More complex problems would be slightly more difficult in order to locate and fix them. But for the most part, these are the 3 steps we need to do. So for the most part, what we did here is basically what we need to learn how to do in order to solve every single problem in this course. Now, like I said in the intro, problem solving is a very valuable skill that you gain with experience. And the way you gain that experience is really by just solving a ton of problems. The more problems you solve, the better you become. So let's go ahead, complete this exercise, and jump onto the next lecture to solve another problem. Hello and welcome, I'm your Code Monkey. Alright, so let's solve the health system problem, the 1003 health bar not updating. So we have the demo, the pistol, the zombie, we click to shoot, and it shoots, and there you go, the bullet disappears, but the health bar does not change. And the problem is that the health bar should be updating. So yep, let's go through our 3-step process. Let's first of all identify the problem. So yep, the problem is the health bar is not updating. So yep, there you go, that one is done. Now let's go ahead and locate the problem. Why is the health bar not updating? So yep, now is the time to pause the video, add a bunch of logs in order to try and locate where exactly the problem is. So pause the video and do that right now. Alright, welcome back. So let's go ahead, add some logs to try and locate the problem. So first we did see that the bullet did spawn, so we can be pretty sure that this code over here is running, so we're testing for the left mouse button and spawning the bullet prefab. So yep, the bullet spawned, so this one is running. Then the bullet was moving right, so this one is running. And then for the collision, it did destroy itself, but it did not cause damage. So let's make sure this code over here is running. So let's call debug.log, Let's print out, make sure the on-trigger enter is working. Then let's make sure it did find the enemy. And then let's also make sure that it is actually dealing damage. So debug.log, try to figure out if it did deal damage, and the damage amount is not 0. So let's try to figure this out. Okay, so let's click, shoots, goes, on-trigger entity, did find the enemy, and did deal damage. Okay, so the problem is not in this code path. The health system does appear to be dealing damage correctly. So let's look at the health bar itself. The health bar is in the world. Inside the enemy, here we have the health bar. And over here on this health bar, we can see, yep, it does have the health bar script. It does have all the references. Those are correct. So let's inspect this script. Now over here, let's try to figure out if this is working. So this is meant to be updating whenever the event is fired. So let's do a log here. So debug.log, try to make sure that the health bar.start is running. And then over here, let's do a debug.log, try to figure out if this event is being fired whenever the bullet does deal damage. Okay, the health bar.start, that one did run. Okay, so that script is attached, it is running, that's good. And now we shoot the bullet, it deals damage. And if there you go, look at that, it did deal damage. But over here, this log never fired. So this function was never called, meaning this event was never fired. Meaning over here, the problem is somewhere in this event, and problem is here on the damage function. We are dealing damage, but we are not invoking this event. So the health bar never knows that the health amount actually changed. So you have the errors right here. With this, we have solved step 2. We have located the problem, and now we really just need to fix it. So in this case, the problem is that the event is not being fired. So over here, we need to fire off the event. So again, now is the time for you to pause the video and try to figure out how to do that, how to fix this problem. Okay, so let's do that. In this case, this is indeed pretty simple since this one is really just a normal event handler. It doesn't even take any extra data, anything like that. So really just invoke the event. To invoke an event, let's do the $.invoke. So this, in case you don't know, this is the non-conditional operator. So it makes sure that this code only runs if this one is not null. Otherwise, you would need to test this one is not null. And only if not null, then you actually invoke it. So using the $, that's just a nice shorthand. Then let's invoke, and this is a nice event handler. So for the object send, let's pass in this. And event args doesn't have any, so let's pass in empty. So yep, whenever the health amount changes, over here reducing it, let's fire off the event. And over here, when we are increasing it, same thing, let's also make sure to fire off the event. So now the event should be fired, and over here, the health bar script, this one should be attaching the listener, that's good. This code was indeed running. So now we should be able to see this one running, which should instead update the fill amount. So yep, let's save everything and let's test. So here we are, pressing the left mouse button, shoot bullet. There it goes. And if there you go, it dealt damage and the health bar did indeed update. Over here we can see the health bar start worked, the collisions worked, it did deal damage. And over here the event, that one was indeed being fired. And the health amount, that one is indeed updating as intended. Alright, awesome. So yep, that's step 3. We have successfully fixed our problem. The health bar is now updating. So yep, congrats on solving this problem. Now let's move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve a problem on the health system. So this problem 1004, the health bar is not updating to. So here the problem is the health bar should update. So here if I click and shoot, and nope, there you go, the health bar is not updating. Alright, so following through our framework, first of all identify the problem. The problem is the health bar is not updating, okay? Now let's locate the problem. So pause the video right now and add a bunch of logs to where you think the problem might be happening. Okay, so let's add a bunch of logs. Now the bullet was being fired, so we don't need to log that. The bullet was colliding with that. So let's first really just do a quick one, just make sure the health system is taking damage. So we can right ahead, just add a log over here. So debug.log, bullet damage, and pass in the damage amount, just to make sure that one is not 0. Let's do a log on this. So if I shoot, and if there you go, it does deal damage. So over here dealing 30 damage. So that seems to be correct. So if the health system is correct, it might be the problem just over here on the health bar. So go ahead, add some logs here. So pause the video right now and try to figure out where should you add logs in order to make sure that this code is indeed running. Okay, so let's do that. So very simple, just over here, let's do a log on the health bar.start to make sure this one is running. And then over here on the health amount changed. On this one, let's also do a log, make sure both of these are logged. And right away, we actually located the problem already. We can see the logs over here, the console is empty, meaning that over here, the health bar.start, that one is not running. And the only way this would not run is if either the health bar component is marked as disabled, or it is simply not attached to any enabled game object. So over here, let's go inside the enemy and inside the health bar game object, and over here in the inspector. Yep, so this is basically the problem. So over here, the health bar game object, this one does not have the health bar component. It doesn't have the component, that is why the start never ran. So yep, we have located our problem, so let's take this. And yep, now it's time for step 3, so let's fix our problem. So yep, now go ahead, pause the video and try to fix the problem yourself. Okay, so let's fix it. Like I said, the issue is that the health bar script, that one is not attached, so let's just attach it. And over here, this one requires these two components, the health system and the bar image. So the health system, that one is over here attached to the enemy. So let's drag the enemy reference and the bar image in order to modify the bar size. Let's go inside, and over here we've got the bar. Let's drag that reference. Okay, yep, so like this, let's test. Try to see if our fix did solve the problem. And if right away we do see the health bar that started, that one did run. Now we shoot, and there you go, it does deal damage, and the health amount does go down, and now the health bar is indeed updating. Over there we can see, yep, the event was fired, dealt damage, so everything is working as intended. Alright, awesome! So yep, congrats on solving this problem. Now let's move on to the next lecture to solve another problem. Hello and welcome, I'm your Code Monkey. Alright, so let's solve a problem on the health system. So let's solve problem 1005, that is the no damage problem. Step 1, let's identify the problem, so the bullet should be dealing damage. If we play the scene, if I click, and if there you go, the bullet does spawn, does go there, but it does not deal damage. Okay, so yep, so that's a problem. Let's try to figure out why the bullets are not dealing damage. So we have identified. Now it's time to locate the problem. So go ahead right now, pause the video and look at all of these scripts and try to figure out where you need to add some logs in order to figure out where exactly the problem is happening. Okay, so let's go ahead and do that. So at least we can verify the bullet is indeed being spawned, and then it is being destroyed. So we can be pretty confident that this code over here is running. Now of course, we can always add a log just to be 100% sure. So here let's do a debug.log, say bullet trigger, and then let's go inside the damage function, and over here let's do a debug.log and say damage. Okay, so let's click, let's look at the console. Yep, there you go, the bullet did trigger and it did actually deal damage. So this code over here is running. Now let's validate that the health amount is working as intended. So debug.log, pass in our health amount, and then after let's pass it in again. So let's test. So as we shoot, yep, there you go, we've got 100. So those two lines of code are running, but the health amount is not changing. And over here, the only way the health amount would not change is if over here the damage amount, that one is 0. So let's do a log on that just to verify. So damage amount, and let's print out the damage amount. Let's see this. So if we shoot, and if there you go, there it is. So damage amount is being passed in as 0. So we can really just go back to see where this function is being called, which is over here on the bolt script. We're getting the component of the health system and passing in damage, and yep, here is the problem. We're passing in a 0 damage amount. So yep, this is where the problem is. So with that, we have located the problem. Now it's time for step 3 to fix the problem, and this one the problem is very obvious. If we want to cause damage, then naturally damage amount cannot be 0. So over here, let's put some other number, let's say something like 3. So we should be dealing 30 damage, so let's see. So here, let's shoot, it damages, and if there you go, now the health bar is indeed updating, the enemy is indeed taking damage. So it took 100, got 30 damage, so ended up with 70, and if there you go, everything is working as intended. With that, we have indeed fixed our problem. Alright, awesome! So yep, congrats on solving this problem. Now let's move on to the next lecture and solve yet another problem. Hello and welcome, I'm your Code Monkey. Alright, so let's solve a problem on the health system. Let's solve the problem 1006, so that is the going under 0 and above the maximum. Let's go ahead and do step 1, let's identify the problem. So here on the scene we can click to shoot, F to heal, so the bullets should deal damage, but the health should not go under 0 or above the maximum. So if we shoot, the bullet goes, does spawn, it does deal damage, and it does seem to be acting correctly. And now if we keep on shooting, yep, there you go, that's the issue. So the bullet is going into the negatives, so the health amount should not go under 0. And the maximum, let's try out the heal, so we are healing, and if we heal more, and if there you go, that's the other issue, it is going above the maximum. Okay, so yep, that's a problem. The health should not go under 0 or above the maximum. So yep, that's a problem. Now go ahead, pause the video and locate the problem. Okay, so let's find where exactly the issue is. So first of all, the damage was working. So we can be pretty confident that over here the bullet, this one is working. It finds the enemy, it goes into the health system, deals damage. And over here, this function is working as intended. It is dealing damage. Let's do a quick log on the health amount just to verify. So do a log on the health amount. Let's print that out. So on the damage function, and then we have some kind of health amount. Let's print that one both here and on the heal function. So this one is the heal function like this. So if we shoot, and if there you go, that one is dealing damage. So damage 70, 40. So the health amount is indeed correct, just like that. And if we go under 0, if there you go, that's the issue. So the health amount is going down into minus 20. Then same thing for the healing. If we heal, we can see the value going up. And yep, the value does go way above 100. So yep, in this simple problem, we can already see where exactly the issue is. It's right here on the health amount. We are doing some math on the health amount. And it's over here that we need to make sure that this health amount does not go under 0 and does not go above the maximum. So yep, with that, we have located our problem. Now it's time to fix it. So yep, go ahead, pause the video and fix this problem. In this case, fixing this problem is very easy. we've got the nice mathf.clamp function. This one clamps a value between a minimum and a maximum. So we can use this in order to clamp the health amount. For the minimum, it is going to be 0, and the max amount is going to be the health amount max. So yep, this one is basically going to return the clamped value. So let's just set the health amount into this. And yep, that should make it work. It should make it so it does not go under 0, does not go above the maximum. Let's just make sure to apply the clamping whenever we do any kind of math on the health amount, which over here in this case, really just these, the damage and the heal functions. So with these two, everything should be correct, so the log should be able to say that the health amount is always staying within that range. Okay, yep, let's save, let's test. So here we are, let's shoot our bullet, and that one is dealing damage. Let's go under 0, so 10 if we shoot again. And if there we go, it goes down to 0, does not go down into the negatives. Now same thing if we heal, let's heal 30, 60, 90, one more, and if there we go, goes to 100. And no matter how much I heal, it never goes above the maximum. And no matter how much I shoot, it never goes below 0. Alright, awesome, so we have successfully fixed our problem. So yep, congrats on solving this problem. Let's move on to the next lecture to solve another problem. Hello and welcome, I'm your Code Monkey. Alright, I hope you're enjoying the course so far. I hope you feel like you're learning a lot. I just want to quickly remind you two things. So first of all, is I really hope you're actually putting yourselves to the test. You're actually putting in the effort to actively apply and actively do all the problem solving, pause the videos and actually try to solve them. Like I said in the intro, I really cannot just force feed my knowledge onto you. You really do have to apply it if you want to gain this super valuable skill. So I really hope you're doing that. And secondly, remember how this course is structured in a very freeform manner. So you can't just follow the lectures step by step one after the other. You can do that if you want. But also, if you want, you can jump around from different scenarios or between different lecture types. Remember how the high-level overview lectures, those are actually at the end of the lecture list. And you can watch those at pretty much any time. You don't have to go through every single one of the scenarios and every single one of the problems before you get to those. Those are a different type of lecture. And on these scenarios themselves, technically you can also jump around. Although the scenarios do sort of build upon one another. Like later scenarios, they use basically the health system and movement system that were built in the previous scenarios. So it might be a little bit tricky to jump between them, but still you can do that if you want. It really just takes a little bit more time to get familiar with those pieces of code because you won't have seen them beforehand. So you have to just keep those two things in mind as you're going through this course. 1, make sure to apply everything, and 2, if you want, jump around a little bit. Alright, so let's continue learning. Hello and welcome, I'm your Code Monkey. Alright, so here let's learn how to make a movement system. Or more importantly, how to take it from that general idea, movement system, and make it into an actual implementation that actually works. So over here, we're going to be following our 4-step design problem solving framework. And this particular lecture, we're going to do step 1 and 2. So we're going to identify the problem and then break the problem down into its core components. So first of all, step 1, let's identify what exactly is a movement system. So for this, I would just say we have some way of moving a player character. So for the most part, that's really it, a movement system. We want to press keys and move an object on screen. I would say that's a nice description of what exactly a movement system is meant to be. I want to be able to press keys and see something move on screen. Okay, so with that, we have identified a problem. Now let's go ahead, break the problem down into its core components. And over here for the movement system, this is a pretty simple one, but I want you to think about this. So think about what exactly does a movement system need to be able to work, to be able to actually be a movement system. Do you need some kind of data? Do you need some kind of behavior? Again, start off as simple as possible. Think about the most basic things the movement system requires. And importantly, focus on the core components. And once again, if you don't know what exactly is a core component, just try to break it down into various pieces and keep breaking it down until you can't break it down further. If you've got some kind of idea, some kind of concept, and you can't break it down into even smaller pieces, if so, then yep, that is the core component. So yep, use whatever you want, pen and paper, paint, just simple text, use whatever you want to try to identify what exactly makes up a movement system. So pause the video right now and do that. Okay, so let's do it. So a movement system, this is very simple. So let's think about the core components of a movement system. We really just need to move an object in all directions. And those directions should be based on player input. It should not be automatically. Although, of course, like I said, you can always refactor, you can always add more things onto it. So for example, later on, you could add some kind of movement system that is driven by AI. But right now, we just want a basic movement system, something that is based on player input. And then it should have some kind of movement speed and should also handle collisions. So it should not go through walls. But we also do want it to interact with other physics objects. For example, push pebbles. So that's it. This is our very simple movement system. We want to be able to move an object in all directions. We want that movement to be based on player input. It should have some kind of specific movement speed. Then we want to have collisions, so it should not be able to go through walls. And should also be able to interact with other physics objects, like push around some small pebbles. So that's it. This is our very simple movement system. These are the core components. Like I said, focus on solving the most basic version first, and then if you want, you can add things onto it. So for example, first we start off by doing this. Then later on, if we want, we can add some kind of teleport mechanics, some kind of dash mechanics, some kind of dodge roll. All of those can be added on top of this later on. First we solve the most basic version, and then if we need to, then we refactor it. Okay, so here we have our nice core components that make up our movement system. Now we can start to think on doing step 3 and step 4, so a high-level overview and implementation details. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. Alright, so here let's take our movement system problem and start to think of a high-level implementation. So let's begin by doing step 3 of our design problem solving framework. So let's do a high-level overview on how to solve each of those core components. So here are the core components. So basically a movement system is some way of moving a player character, press keys and move an object on screen. Then in terms of the core components, we should be able to move an object in all directions. It should be based on player input, should have some kind of movement speed. It should handle collisions, so it should not go through walls. And it should also interact with other physics objects like pushing some pebbles. So now it's time to do step 3 of our design problem solving framework. Go ahead, take all of these core components and try to figure out how you can come up with a high-level overview on how you could implement this. Again, think about it how in this point, right now we just want to think in pseudocode. It does not have to be valid C#, does not have to be valid syntax. Just a high-level overview on how you could implement this in some kind of programming language. So think about what data do you need to store, what data structure, what behavior, what does it need to do. So yep, that's the challenge right now, so pause the video and do that. Okay, great, so let's think of a high-level overview on how to implement all these core components. So first, moving an object in all directions. So for that, we're really just going to move an object, then making it based on player input. So we're going to test for keyboard input. Let's test for the WASD keys, and then create a movement vector based on those. Apply that movement vector to object. So this is basically how we're going to be based on player input and apply that to the actual object movement. Then of course we need to define some kind of movement speed. So that is going to be some kind of variable movement speed that is then incorporated in the logic that we apply for moving the object. And for all this logic over here, so test for the keyboard input, WASD, we're going to test this on every update, on every single frame. We're going to constantly need to test for that over and over again. Then for the collisions, use a physics system and make sure the object is solid. We don't want it to go through walls, but also make sure it's capable of pushing objects. So I would say this is a nice high-level overview on how we can implement the system through code. We want to move the object. We're going to test for keyboard input, specifically WASD, and we're going to test that on every update because the player won't be pressing different keys. Then we want to create a movement vector based on those keyboard inputs, and we're going to apply that movement vector to the object. That is basically how we're going to implement these nice core concepts. The idea that we can move an object in all directions and how it's all based on player input. Then we're also going to have some kind of variable movement speed that we're going to incorporate into that movement. In order to solve all the collisions, all those things, for that we're going to use the physics system to make sure the object is solid, so it does not go through walls, and make sure it's also capable of pushing other objects. So with this, we have solved step number 3. We have thought one level lower, one level deeper. We've got some rough pseudocode for how we can implement this. And now it's time for step 4, which is turn this pseudocode into actual C# code. So for that, let's go here onto the movement system, onto the exercises, and let's open up the exercise scenario to do. And here we have a nice scene. So we've got a player object in the middle. We've got some nice pebbles and we've got some walls. So we have everything we need to create the exact movement system we want. Now it's time for us to take this pseudocode and make it into actual and proper code. Now in this part, I should also mention how for this step, there are usually a million possible implementations for you, how you can do this. This idea that we have here, we can implement this in the code in many, many different ways. For example, in Unity specifically, when it comes to moving an object, you can move a rigid body, you can move a transform, you can move a game object. When it comes to testing for keyboard input, you can use the input manager or the input system. When it comes for WSD, you can use that or use the arrow keys on any other keys. When it comes to creating a movement vector, you can create either vector 2 or vector 3. When it comes to movement speed, that can be an int or a float. When it comes to the physics system, it can be either the 2D or 3D one, or it can be your own custom physics system. So yep, basically my point is we have this nice rough blueprint, and now there's a billion ways for us to implement this. So I want you to go ahead and do step 4 by yourself. But keep in mind how if you come up with some implementation that happens to be different from the one that I do, that does not mean you're wrong. If you achieve the goal of taking this and making it into some actual code that actually works, if so, then congratulations, then you have made it. It doesn't have to be exactly like the way that I'm going to implement. So I really just want to stress that point. There's a billion possible ways to implement pretty much any system you can think of. So as long as you solve all of these requirements, all the requirements that we defined, as long as you do that, then your implementation is just as valid as mine. So yep, go ahead, pause the video right now and turn this pseudocode into actual C# syntax. Alright, so let's do that. Here I'm going to begin by creating a new C# script. So let's go ahead, call it the movement system. Let's wait for it to compile. And then let's go on the player game object. Let's attach our movement system and open it. Okay, so now here, let's start implementing our nice pseudocode. So first we're going to want to move the object. And here, like I said, there are many possible ways to do this, but let's do it on update. And to move, we can either move the transform.position, so this is a possible thing, we move it by the movement vector, or alternatively, since our goal is to use physics, if so, we can also use the physics system to automatically move the object. So over here on the inspector for the player game object, I already attached a rigid body 2D component, as well as a box collider, meaning this is going to be using the physics system. So you can just take advantage of this in order to move the object. So over here, we can just get the rigid body component. So let's do that on awake. Let's grab our nice rigid body component. So private rigid body, and importantly in Unity, always remember how the 2D and the 3D physics system, those are completely separate. So always make sure you don't make that mistake. In fact, some of the problems that we're going to solve are very much related to this. So we want the player rigid body 2D. So we have this, and on awake we do that, get component of type rigid body 2D. Okay, we have it. And then on update, we're going to set the linear velocity to some kind of movement vector. So this is where we're going to do the other ones. So we're going to test for player input for WASD, and we're going to create movement vector based on those. So first let's test. And again, here we can use either the input manager or the input system or pretty much anything we want. In this case, I'm going to be using the input system. So for that, the easiest way is to use the keyboard.current. Then let's check for the W key. Then was press is frame. Then is press to test if the key is actually held down. So if we're currently holding down W key, let's create a movement vector. So let's create, and again, we can use either vector 2 or vector 3. Since I'm working on a 2D game, I'm going to be using a vector 2. Let's say this is the move vector. We start off as an empty 0, 0 vector. And then if we press the W key, let's set that one.y into something, let's say just 1. Then let's test for all the other keys. So we've got the W, then we've got the S, which is going to be -1 on the Y. Then we've got the A, which is going to be -1 on the X. And then we've got the D, which is +1 on the X. So we have the movement vector, and over here we just move it by that amount. Now the next step of our design is we need to apply the movement. Now the next step in our design is apply the movement vector to the object. Yep, we already did that. So then we need some kind of movement speed. So over here, let's define that. And we can either define it up here if we want to expose it into the editor. Let's do a serialized field, private float, make a movement speed like this. And then over here, we're simply going to incorporate into our math. So movement vector times our movement speed. And if that should move our object, we can do a quick test to verify. Okay, so let's make sure the movement speed is attached. Let's give it some kind of movement speed. Let's say something like 4. That should be enough. So let's go ahead and test. Okay, so here we are. So far, so good. If I press on W, and there you go. It does start moving up, right, left, down. So I can move up, can move down, can move right, left. I can do any combination of those. And yep, we do have an object that is moving exactly as intended. All right, awesome. Okay, so far, so good. So we have successfully implemented a bunch of these. Now we just need this one. Use the physics system, make sure the object is solid. So we actually don't want this player to go through these solid walls. And actually, just by doing this, we actually have already implemented this. Same thing for the last one, make sure it's capable of pushing objects. So with this setup, this over here, we are using the player rigid body and modifying the velocity. Because this, it should already be not going through these walls, and should already be colliding and pushing these objects around. So let's do a quick test. So if I go and try going towards the wall, and there you go, I cannot go through the wall, that's awesome. And if I push these things around, yep, there you go, they do work, I can push them around, they rotate, they move around, everything works alongside physics, everything is nice and awesome. All right, great. So up here we have solved yet another problem. We've built a movement system from scratch. We first broke it down into the core components. Then we took those core components, we went one level deeper and thought about a high-level pseudocode overview, and then wrote an actual code implementation of that, something that actually uses correct C#. And we did a quick test and realized that, yep, everything works fine. We have all of our requirements, everything works perfectly. So yep, we've built a nice movement system. Now let's figure out how to solve all kinds of problems related to this system. Hello and welcome, I'm your CodeMonkey. Alright, so here's a quick recap of the movement system demo. So here's the basic scene that we're going to be using throughout all of these exercises. This is actually a very simple one, it is literally just one script and that's it. Over here, if we hit on play, we have a character in the world, and using WASD, we can easily move the character in any direction. Then we've got the black, these are solid walls, so we cannot go through them. And then we have these gray pebbles, these are physics objects, and we can push them around. So in terms of setup, over here for the player object, it has a rigid body 2D and has a box collider, and then it has the movement system. For the walls, they simply have a collider not set as trigger, so it's meant to be a solid object. And for the pebbles, those have a rigid body, so they can move around as they are pushed. And then they've got a circle collider, and again, this one is also not marked as a trigger. So if that's basically this demo, then we have the movement system. And over here, I actually implement this multiple different ways. There are various ways that we can basically move it. We can either do a box cast, a physics cast like we're doing here, in order to manually identify all the walls and be able to either move or not move the object. Or other implementations of this demo simply use the rigid body velocity, sets that, and basically the rigid body itself will handle the collisions. But for the most part, the way it works is very simple. We've just got on update, we test for the input keys. we calculate a movement direction, and then just move in that direction alongside a certain move speed, and just keep going until it hits something. So that's really it. This is a very simple demo. This one really just has one script. So now, based on this scenario, now let's start solving some problems. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve a problem on the movement system. Let's solve the one 1102. This one is called not moving. So first of all, let's identify the problem. So here we are, and if we press W, A, S, and D, we should be able to move, but nope, as we press, nope, it is not moving. So yep, this is the problem, the player is simply not moving. So yep, we have identified it. Now go ahead, pause the video, and try to locate the problem. Okay, so first of all, let's begin by opening up the movement system. And over here, let's set some logs to make sure this one is running. So let's first verify the code is actually working. First we do that, and then we see what else might be wrong. So first of all, let's add these logs. And now if we test, let's look in the console. And right away, we have actually already located the problem. There's nothing in the console, meaning these logs aren't running, not even this one, not even the awake one, meaning this script is probably not attached to anything. So yep, with that, we have located the problem. And now to fix it, this is very simple, but still, if you want, go ahead, pause the video. So over here, let's just check either the script is not attached or it's simply not enabled. So let's go on the player and look in the inspector, and if there it is, simply does not have the script. It's got the rigid body, it's got the box slider, but no script. So if we just attach this, if we now test, and now as we move, and if there you go, now it does move, and it works perfectly fine. All right, awesome. So yep, congrats on solving this problem. We have managed to fix it. Now let's go ahead and move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve an exercise on the movement system. Let's solve this one, 1103, called error. So over here, the goal is the player should be able to move. So let's go ahead and let's identify the problem. So over here, as we press the keys, and nope, it is not moving. In fact, if you look over here on the console, we do see an error. We've got a missing component exception. So that's it, we have identified the problem. Now go ahead, try to pause the video and try to locate the problem. In this case, since we have an error, it should be pretty easy in order to identify where exactly this is happening. So over here on the script, by looking at the stack trace, we can see the error is happening here. So on the movement system.update, and it's a missing component exception, which is really just saying how there is no rigid body 2D attached to the player. Here in the script on the update down here, we can see, yep, this one is trying to access the rigid body in order to set the linear velocity, but it is failing because this one does not exist. So over here, if we look on the player, if we look in the inspector, and if right away we do see a nice issue. So this is one of those common issues. We do have rigid body, however, this is a rigid body. It is not a rigid body 2D. Same thing for this. This is a box slider and not a box slider 2D. Always remember how the physics systems are completely separate. You cannot mix 3D and 2D components. So yep, with that, we have located the problem. And now fixing it, this is very simple. Just over here, let's get rid of these 3D components. And let's add a rigid body 2D. And then add a box slider, also the 2D one. Then we can play with these settings, like for example, for the rigid body, since it's meant to be a top-down game, we should be able to set the gravity scale back down to 0. In order to make it nice and smooth, let's set it to interpolate, and for the collision detection to be a bit better, let's set it to continuous. And again, since this one is pretty much top-down, let's also make sure to freeze on the rotation. So yep, that one should be working. Let's just go over here and make sure that the collider also has the rough shape of our character, so kind of like this. Okay, so now if we test, and if there it is right where we don't have any errors in the console, and if we move around, if there you go, it works and interacts with all the 2D physics objects exactly as intended. Alright, awesome! So yep, congrats on solving this problem. Let's go ahead and move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve an exercise on the movement system. Let's do 1104, movement inverted. So first, let's just identify the problem. Let's set on play. And over here, if I press D, and yep, it's actually moving left instead of right. And if I press A, it's moving up there. If I press W, it's going down. Press S, and it's moving up. So yep, the movement is very much inverted. So yep, this is our problem. Now let's go ahead and locate where that problem is. So pause the video right now and do that. Since this demo really just has one script, that is actually very easy. We can look over here inside the movement system, and this is a common easy error. It's just over here where we're testing for the key inputs. So the A key, this one should be moving left, meaning for the X, it should be moving -1. Then for D key, it should be moving to the right, so +1. W should be moving up on the Y, so +1, and S -1. So yep, with this, we have both located and fixed the problem. That's really it, it's just having the wrong values over here. Now if we test, so here if I press W, goes up, S down, D right, and A to the left. So there you go, everything works and interacts with everything, and everything works as intended. Alright, awesome. So yep, with that we have quickly located and fixed our problem. Okay, so congrats on solving this one, and let's move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve the problem on the movement system. Let's solve the problem 1105, no diagonals. Okay, so first of all, let's identify it. So here, if I press W, it goes up, S goes down, D goes right, A goes left. So that seems to be correct. But now if I press both W and D, and if there I go, it's only moving right, it is not moving right and up. And if I press A and W, it's moving left, S and D, and it's moving right. So I cannot move straight in diagonals. I can only move in these four directions. So yep, we have identified the problem. That's the issue. Now let's go ahead and locate it. So go ahead and do that. We can inspect our script, and over here, let's look at it. And just by looking at it, you can probably already tell the issue. The character is moving, so we can be pretty confident that this line of code is running. So the issue is somewhere in the logic around here. So that's basically it for locating it. So you can go ahead and mark step 2 as done. And now if you want, pause the video and try to fix it. In this case, the problem is very obvious. So the problem is right here, we are doing if and then else. Which of course, if we do that, then first it's going to test for this condition. Only if this one is false, does it then go into this condition. Does the else, does the if, and then if this one is false, then it goes into this one, and if this one is false, then it goes into this one. Meaning there's never a point where it actually tests both of them, because if it goes to inside of one of these, then it does not go inside any of the other ones. So if we press both A and W, then it's really just going to trigger over here the A, goes inside of this one, and never actually tests if the W is down. So the problem here is we should have 4 independent ifs as opposed to if else. So if we just get rid of all the else's, now if we try to move, and I move right and up, and there you go. Now diagonals do work. I can move diagonally up, down, left, right, and everything works perfectly. All right, awesome. So yep, congrats on solving this problem. We have indeed fixed it. Now let's go ahead on to the next one. Hello and welcome, I'm your Kudmaki. So let's do an exercise on the movement system. Let's do 1106. This one is not colliding on walls. So let's go ahead and identify it. Okay, we have the character and we can actually move it around. Okay, that's great. And now if we try going through the walls, and if there you go, it goes through it. Whereas this should be a solid wall. Let's see on the pebbles. And these, they do interact, so that's nice. And interestingly enough, the pebbles are going through the solid walls. So we have a bunch of info already. But yep, we have identified it. The issue is it is not colliding with solid walls. So now it's time to actually locate the problem. So use this information, try to locate it. Pause the video right now and give that a go. Okay, so the fact that the pebbles also went through the walls, that makes me think how the possible issues, how the walls themselves do not have a collider. So let's begin by looking into that. Let's locate the problem by looking on the walls. And if we look inside the wall component, and if right away we actually do see the issue on this wall and this wall over here, yep, they both have the exact same issue. Over here, the code is all fine. The issue is really just over there on the inspector. So yep, we have already located the problem, and you probably already figured out how exactly to fix it. This is once again that common error. If we look inside the walls, we can see on the inspector, yep, they are using the 3D box collider components. Again, as always, do not mix them. So over here, let's get rid of this. Let's replace it with a box collider, the 2D version. And yep, just like this, it should work. So if we hit on play, and now if we go and try to touch, and actually, nope, it still has an issue. However, we have already fixed one issue, which is on the pebbles. If I push that pebble around, if there you go, look at that, the pebble is actually colliding with the wall, so the pebble is working correctly. However, the player itself, the player is still going through walls. So this problem is actually 2 problems in one. We have solved one of them, so we have replaced the 3D collider for a 2D one, but now we have another one. The player is moving through walls, and the reason for that is over here on the setup for the player itself. Over here, the player is set up as a kinematic rigid body, and kinematic means that the script itself is responsible for moving the object, and it means that the physics system will not apply forces onto this object. So normally, if we go through inside this wall, normally the physics system would push this object out of it, but since it's kinematic, the physics system is not applying anything onto this one. So the solution to make everything collide is very simple. Just over here, instead of kinematic, let's make it dynamic, meaning now this object will be impacted by the physics system. And now if we try moving left, and if there you go, now it hits the wall, and again, the physics system is applying a negative force onto the player to make sure it does not go inside the wall. So like this, we can collide with all of our pebbles, we can hit those, and we can hit over here. And yep, all the walls work fine, the pebbles work fine, everything works fine. Alright, awesome. So yep, like that, we have fixed our problem, everything is solved. So congrats on that, and let's move on to the next one. Hello and welcome, I'm your Kudmaki. Alright, so here let's learn how to design a nice enemy AI. We're going to follow our 4-step framework, so as always, let's begin by identifying what exactly is the problem, what exactly is an enemy AI. And for this, obviously when it comes to AI, you can mean a lot of different things. So in this specific case, I really just want some very simple AI. So in here, my definition for how I identify what exactly is the enemy AI that I'm trying to build, I'm just going to say that I want various states with various behaviors, mainly find and attack targets. So this is the basic idea of what I want to build. This is exactly what I'm calling enemy AI. So then step 2, so let's break the problem down into its core components. So here let's stop and think, what are the core components that I would want based on this description? Now on this one, there's a million ways to define this. Like I said, this can be very broad. So I want you to pause the video and try to come up with a definition, even though you are probably not going to come up with the exact same as me, but that's fine. Just try to break down this definition into its core components. So yeah, pause the video right now and do that. Okay, so here for the kind of NMEI that I'm going for, like I said, I just want various states with various behaviors. And for the behaviors, I want some kind of state looking for target. And on the state that I really just wanted to find a target, then I want to have a state for chasing target. This state really just move towards target until close. And finally, I want some kind of state for attacking target. And this one, I just want shoot bullets at target. So if these are the core components for what I'm calling my NMEI, I really just want 3 different states, so looking for target, chasing the target, and attacking the target. And within those, then this is basically all I want to do. So in this case, just find a target. In this case, just move towards the target. In this case, just shoot bullets at the target. So yep, these are the core components that I want to build for this NMEI. Now let's go ahead and do step 3. So think of a high-level overview on how to solve each of these components. So in this case, in terms of thinking how we might implement this, so first we're going to need to define some kind of target. So I would say we're going to define an enum for the various states that we can have. Then we're going to have those states, so the state looking for target. And under this state, in this particular demo, I just want to move left automatically just so it automatically finds the player. Again, we're going to see this in a little bit in the demo. Then I want to do a physics query to find the player target and make sure it finds it within a target distance. Then on this state, when found, change to chasing target. So then we have the next state. We have the state chasing target, and over here on this state we'll just want to move towards target until within attack distance, and then when close change to attacking target, and finally we have the state attacking target, and on this state we want to aim at target, then we want to count down a timer, and we want to fire bullets. So if this is a nice high-level overview of what we want to build, so we need to first of all define some kind of state enum. Then we're going to have these 3 different states looking for target, chasing, and attacking target. Then on this state over here, we're going to want to move left, do a physics query to find the player target. Then when found, change to the next state. And on next state over here, move towards the target until within the attack distance. When that happens, change to the attacking target. And in this attacking target state, on this one, just constantly aim towards the target, which is the player. And then count down some kind of timer. And when the timer is elapsed, then fire some bullets. So here we've got some nice pseudocode on what exactly we would like to build. This will be an interesting NMEI scenario, so let's go ahead and implement this. Here on the NMEI lecture, let's open up the scenario to do. And here it is, and right now if I hit on play, then nothing happens because the enemy doesn't have any sort of NMEI. And over here we see a bunch of scripts, and the main one is really the NMEI script. So here it is, and I just left a bunch of pre-prepared functions just to do the things that we want to do on each state. But importantly is right now it's not doing anything, so we want to implement some kind of NMEI. We want to take this nice pseudocode and convert it into actual code. So yep, go ahead and do that now. Pause the video and convert this into proper C# code. Okay, so let's do that. So first of all, we want to define an enum for the state. So that's simple. Over here, just define a private enum for the state and just define our various states. So we've got looking for target, we got chasing target, and we got attacking target. Okay, those are the various states. And then we need some kind of variable to store our current state. So state for our state variable. And let's start off on something. So let's do private void awake, set the state equals looking for target. Okay, that's great. And now the way that pretty much any kind of state machine works is on update, we should do a switch on state. So pretty much like I've got here. So let's do a switch on this, and we're going to have our various states. So we've got looking for target, chasing target, and we've got the attacking target. So yep, we've got these nice 3 states. And now I'm looking for target. So on this one, we want to, first of all, move left. So over here, I actually left this nice simple function, move left. So yep, this one is very simple. Just moves the transform position towards move left according to move speed by delta time. That's it, very simple. Then we want to do a physics query to find the player within the target distance. So let's go ahead and implement this. For doing a physics query, let's use the physics 2D. Again, don't mistake 2D and 3D. And let's do an overlap circle, or actually overlap circle all, so we can find all the colliders within range. Within range of this object, so transform that position, and within the radius, which is going to be some kind of find target distance. So let's set this to something like 3F, and like this we're going to test, and this is going to return an array of collider 2D. So our collider 2D array, and then just do a for each collider 2D on the collider 2D array. And then the goal is to actually find the player target. So over here, let's check the collider 2D try get component of type player, out player like this. So this is going to find our player target. So if this one succeeds, then we have indeed found the target. So according to this, when found, we want to change to chasing target. So over here, if we find the player, then set the state equals state.chasing target. Okay, so that's great. So that's pretty much it for the looking for target. We're really just following our code step by step. So we want to move left to physics query and so on. So we're basically just converting the pseudocode into actual C# code. This is why it is so much easier to start off with pseudocode. We just start off with a rough idea of what we want to build, and then we actually focus on writing the actual syntax. So then on the chasing target. On this state, we want to move towards the target until within attack distance, and when close enough, change the state. So over here, let's move towards the target. So transform.position plus equals, let's calculate the move direction. So vector 2 for the move direction. And we start off with the player, and the player has a static instance that we can easily access. We can get to transform.position minus this transform.position. And we're going to have the move direction, and let's make sure to normalize it. Okay, we have that, and then this one times the move speed times time.time. So if that is going to move our nice target, and this actually should be a vector 3, so it doesn't cause an error. Okay, great. So move towards the target until it is within attack distance. So you float for attack distance, let's say 1f, and then just check if it's close enough. So if vector 3.distance between the player instance transform.position and this transform.position, if that is under the attack distance, if so, then we want to change the state equals to our state.attacking target. So if that's it, following our nice pseudocode, we move towards the player, and if close enough, then we change the state. And finally, on state attacking target, we want to aim at the target, count down the timer, and fire some bullets. So over here, we've got this function to aim a pistol at the player, so let's constantly aim whilst attacking the target. Then let's count down some kind of timer. So here, let's find a float attack timer. So we have this, and then over here, this one count down by time.time. And if the attack timer is under 0f, if so, let's first reset it. So let's set it to some kind of attack timer max. Find this one. Let's say 0.5. So we fire a bullet every half second. We reset the attack timer, and over here, fire the bullet. So that's this function, shoot bullet at player. Okay, that should do it. We aim, we count down the timer. When the timer is elapsed, we shoot a bullet and reset the timer. So yep, over here, we have pretty much converted all of our nice pseudocode into actual C# code. Let's do a quick test, see if it's working. So let's hit on play. There you go. Starts moving left, and now moves towards the player. And now when close, yep, there you go. Aims towards the player, fires the bullet, and there you go. It is attacking. All right, awesome. So yep, that's really it. We just implemented a really nice, simple enemy AI. We started off from a rough idea on what we want to build. We want to build an enemy AI. Then we defined what exactly does that mean, because again, there are multiple ways that we can build some kind of AI. There are multiple meanings as to what that means. Then we came up with the core concepts of what we want to implement. So we want to have different various states. And then we converted that into some nice pseudocode, a nice high-level overview on how we could implement that through code. And then we wrote the actual implementation. We defined our states, we set up the update, doing a switch on state and doing different logic depending on the state. And final state is the enemy approaches. Now it goes straight towards the player. Now shoots the player. There you go. Everything works fine. All right, awesome. So great job on building this enemy AI. And now based on this, let's solve some problems. Hello and welcome, I'm your Code Monkey. Alright, so here's a quick recap overview of the enemy AI demo. So over here, if we hit on play, we can see the enemy starts moving left, then once it gets within the range of the player, it moves towards the player, and once it gets within the attack range, starts shooting, and then it just deals damage to the player, and the player eventually dies. So yep, in terms of behavior, it's very simple. It's really just a basic enemy AI. Then in terms of the code, this is made up of a handful of scripts. So first of all, we have the health system. So this is really the same health system that we built in this course. So we really just have a basic health amount. Then we've got a damage function, a heal function, and a bunch of functions to get the health amount, test if it is that, and so on. Then we also have the health bar script. So for this one, we've got the health bar game object, and this one has the health bar script. And this one really just has an image, and that image is set up to fill, so we can basically modify this amount. And then the script for it. So this one takes in a health system and takes in the bar image. It really just listens to the event on the health system and really just sets the fill amount to the health amount normalized. So if the health system is very much the same that we've been in this course, then we also have a player script. So this is really just an empty script. This is really just used as a tag script. Over here on the player game object, yep, this one has a player script. Again, this is really just to identify that this object is a player. And then we have the bullet script, so this one is attached to the bullet prefab. And this one over here, first of all, it has some cleanup code, so after 3 seconds the bullet is destroyed. Then on update, really just moves the position to move the bullet. And then for testing for hits against the player, it uses the physics system, so it tests for a trigger collision. When it happens, it tries to find that player script component. And if it does, then it gets the health system for the player and deals some damage. So yep, those are the main components, and of course then we have the AI itself. So over here on this one is really just a basic state machine. So we've got a handful of possible states. So the enemy can be looking for a target, it can be chasing a target, and it can be attacking a target. So over here we've got a field to store the current state, and we start off as looking for target. Then on the state looking for target, over here we basically just move left once in this state. So that is why the enemy starts off and just moves left. Then every time it does, it's constantly testing and seeing if the player is within range. So over here it just does a physics query, does an overlap circle, and tries to find all the colliders nearby this enemy that are within this target distance. If it finds them, then it cycles through them, tries to find the player component, and if so, that means the player is in range, so it goes into the chase state, and then over here just moves towards the player, then tests for distance if it gets within a certain attack distance. If so, then it goes into the attacking state, and finally over here on this state, first it just rotates the pistol in order to aim towards the player, and then just counts on a simple timer just so it doesn't attack on every single update, and counts on, and when the timer's elapsed, really just spawn the bullet, and then again, then the bullet really just moves forward, which will eventually hit the player, deal damage, and so on. So yep, if we hit on play, we should be able to see the enemy. First of all, it goes left, then finds the target, moves towards the player, and when it gets close, aims the pistol towards the player, starts shooting, and there you go, the bullet deals damage. Alright, awesome. So yep, so this is how the enemy AI scenario is set up. Now based on this scenario, let's start solving some problems. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve a problem on the enemy AI. Let's solve problem 1402, attacks too far. So as always, first let's identify the problem. So the problem appears to be the enemy attacks from too far. It should chase the player until close, and only then it attacks. So in this case, it really should only attack when the enemy is around this position. This is way too far, this is way outside the range. This is not what it should be happening. So yep, that's a problem. Something is wrong, it is attacking from way too far. We have identified the problem. Now go ahead, pause the video and try to locate it. So the first thing we should do is add a bunch of logs on the enemy AI, try to see what state are we currently in. So over here on the update, let's just do a debug.log on our current state, try to see if it does go through all the states, and if we play, and okay, starts off looking for target, then let's collapse so we can see all the messages, and yep, it went from looking for target, so it started off on that one, but then it chased, and chased literally for just one frame, and then got straight onto attacking. So based on this, I would say we already have a very good hint as to where exactly the problem is. Based on this, it seems like the issue is over here somewhere on the code for the chasing state, because there's really no way, no reason why this one should really only stay in this state for just one frame. So the issue is somewhere over here within this code. So yep, with that we have located the problem. Now pause the video and try to fix it. And over here, I actually already noticed what the problem is, just because it's a common problem. But still, let's do a debug.log on the distance to player. Let's see, is this one correct or not? It should only attack when it is within 2 units. And okay, as it approaches, and yep, look at that. So as it goes into the chase state, it is 4 units away. That is more than 2, so it should not go into the attacking state, but it does. And the reason for that is the distance is being calculated correctly. The 2f over here is calculated correctly. Of course, the issue is right here on this math. We are testing if distance to the player is bigger than the attack distance. If so, we go into attacking, which of course that is not correct. We only want to go into the attacking mode if we are closer than that distance. So over here, instead of being bigger than, it should be smaller than. So if that's it, just as one change to solve it. Now if we test, and the enemy starts off there, goes left, and there you go, now it does go towards the player, approaches the player, and yep, only when it's within 2 units, only then does it actually attack the player. Alright, awesome! So yep, we have fixed the problem. So congratulations on finding the solution, let's move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve a problem on the enemy AI. Let's solve problem 1403, aim wrong. Okay, so first let's identify it. Apparently the enemy is not aiming at the player. Okay, so the enemy goes left, chases the player, and if for some reason it is aiming all the way down here as opposed to being over there onto the player. And since it's not aiming towards the player, of course the bullets don't hit, they don't deal damage, so nope, this is not correct. There's something wrong in this logic over here. So yep, we have identified the problem. Now go ahead, pause the video and try to locate it. So first let's go on the enemy AI script, and over here since the issue is on the aim, we can go straight to that piece of code. It's over here on the attacking state. So this one calculates the aim direction, then sets the pistol transform that right, which should then aim towards that. So let's actually do a log over here on the aim direction, try to see what this one is returning. So over here the player is to the left and above, so it should be somewhere with a minus on the x and a positive on the y. So let's see what that vector says. And okay, there you go, that's the issue. Instead of being negative on the x, it's positive. Instead of being positive on the y, it's actually negative. And just by looking at it, we can actually see how it seems to be aiming at pretty much the opposite direction. It is going down to the right as opposed to left and up. So yep, it seems the issue is right here on the math that we are using for the aim direction. So yep, that locates the problem. Now go ahead, pause the video and try to fix it. And this one is a very common problem. It is mistaking how you calculate some kind of direction. I must say I've made this mistake many times myself until I got to the point where now I'm pretty sure that I have it memorized. Whenever you want to do this type of math, it is always the target minus the current position. So if we want to aim towards the player, so this is the target, so it should be this minus the transformed out position, which is going to be the current position. So yep, target minus current, and if we do this, now the aim should be correct. So yep, let's test. Okay, he goes, approaches, and aims, and there you go, now it is correct. Aims, shoots, damages, yep, everything works fine. Alright, awesome, so with that we have fixed the problem, so congratulations, let's move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve a problem on the enemy AI. Let's solve problem 1404, does not attack player. Okay, so first let's identify it. Apparently the issue is it does not attack the player, so the enemy goes left, and yep, there you go, it just keeps going left, so it never actually finds the target, never moves toward the target. Nope, the enemy just keeps going left. So that's the issue, it should be able to find the target, meaning the player should be the target. So we have identified the problem. Now go ahead, add a bunch of logs to try to locate it. So first we can just verify that the states are actually working as intended, meaning that this one's actually staying as stuck as looking for a target. So doing a debug.log over here on the current state, let's see what this one says. And he's going left, and yep, there you go, he is constantly looking for a target, he never goes into anything else. So based on this, we actually already have a nice hint as to where exactly the problem might be. If we are getting stuck on this target, that means there's something wrong over here with this state transition. This is where we do transition from looking for target into chasing. So if we're never going to this, there is something wrong over here in this code. So yep, I would say we have located the problem. Now go ahead, pause the video and try to fix it. So on this one, there's actually a handful of things that could be. First of all, let's see if it's actually finding a collider. So let's do a debug.log on this collider, try to see where it is. Either it's not finding any colliders in range, or it's not finding any collider that does have the player component. Those are basically the only two possible options here. So as he goes left, there you go, he's actually finding the player. So it does seem the physics query is working correctly. He does find the player game object within range. So that means if we look on the player, this one, yep, it does have a box collider. So if it does find a collider, the only possible way for this to not run is, of course, if the game object does not have the player component. And if we look over here on the game object, we can see this one, so this is the player. It does have a box collider, that is why it is found by that physics query. But yep, this one just has a health system, it does not have the player component. So that is why it does not have it, therefore it doesn't attack it. So let's fix this, let's add the player component just like this. And now we can test. And now we should approach, find the player, and there you go, moves towards the player, then shoots, and everything else works fine. Alright, awesome. So here are the states, all of them working. We have successfully fixed the problem. So congratulations, let's move on to the next one. Hello and welcome, I'm your CodeMonkey. Alright, so let's solve a problem on the enemy AI. Let's solve problem 1405, enemy does not attack. Okay, first of all, let's identify it. So the problem is the enemy does not shoot the player. Okay, so the enemy goes left, finds the target, goes there, but yep, there you go. It is aiming correctly, but it is not shooting. Okay, so that's interesting. Something's going wrong here. So we have identified the problem. Now let's figure out why the enemy is not shooting the player. So pause the video right now and try to locate it. Let's go here on the enemy AI script. And first of all, let's just verify the states are working as intended. Let's make sure that it is actually going into the attack state. So over here it goes left, then approaches, going looking for target, chasing, attacking, and yep, it is currently on the attacking state. Okay, so the state machine does seem to be working correctly. So if the states are working correctly, let's see over here on the attacking state. There is something wrong over here. The aim direction, that one did seem to be correct. The pistol was aiming in the right position. So let's test out over here for the attack timer. This one should be constantly counting down, and when it's under 0, that's when it should be actually firing the bullet. So let's see if this one is not counting down or something is wrong. Okay, so he goes left, he attacks, and yep, look at that. So that one is correctly counting down, but it is going under 0 and it is not shooting the bullet. So there you go, the issue is somewhere over here. So yep, I'd say we have located the problem. Now go ahead, pause the video and try to fix it. And over here the fix is actually very simple. As we saw, the attack timer, that one is correctly going under 0, but over here we're actually testing bigger than 0. Now, of course, when it comes to timers, you can either count down or count up. It doesn't really matter. But of course, if you count down, then you should check if it's under 0. And if you over here decide to count up, you should check if it's above the maximum. So let's say I do want to count down, because usually I do like to do a countdown. If so, then over here it should be under or equal to 0. So like this, basically every half second, it should correctly fire the bullet. Yep, let's test. So here we are, he goes left, approaches, and if there you go, he does aim, he does shoot, and over there we can see the counter goes down under 0, and then resets, goes back up, and continues firing, continues shooting. Alright, awesome. So yep, there you go, that fixes the problem. So congratulations on solving this one, let's move on to the next one. Hello and welcome, I'm your Code Monkey. Alright, so let's solve a problem on the enemy eye. Let's solve problem 1406, the player is dying in one shot. Okay, so first of all, let's identify it. So let's hit on play and try to see, does the enemy move left? Yep. Does it find the target? Yep. Does it shoot? Yep. And there you go, that's the issue. So apparently it is killing the player in one shot. That is not correct. The bullet should be dealing only about 10 damage. So it should not kill the player in just one shot. That's the problem. Now go ahead, pause the video and try to locate it. So on the enemy, it actually seemed to be correct. Over here, it was correctly aiming and shooting towards the player. So we can be pretty confident this code here is working correctly. So let's see the bullet. Let's see where it actually deals damage. So here's the bullet script. It should be able to find the player component and deal damage. So over here, let's do a debug.log. See this one on trigger, enter to the damage. Then let's go inside damage function. And over here, let's do the health system damage and pass in the damage amount. And then let's also print out the current amount. Just make sure this one does not go under 0. So the current health amount. Okay, like this, let's test. Okay, so we can see goes left, goes up, aims, shoots, and okay. So we can see, yep, that one basically went down to 0 right away, but over here, it actually did not go down to 0. So it is dealing 10 damage every time, which is correct. And then the health is going down to 90, 80, 70, 60, 50. So that one also seems to be correct. So if the health amount is correct, then the issue perhaps is actually on the visual representation. So let's go on the health bar, let's inspect the health bar script. And over here, let's say the health amount normalized, let's see what this one is returning. So for example, the first time we shoot a bullet, it should have 90 health left. So this one should say 0.9, then 0.8, 0.7, and so on. So yep, let's see. Okay, so there it goes left, goes up, and shoots, and okay, there you go. That's our error right away. So over there, the health amount normalized, that one is returning 0, as opposed to returning 0.9. So yep, that's the issue. We have located the problem. Now go ahead, pause the video and try to fix it. And this is one of those common problems that we've already seen previously in this course. Over here on the health amount normalized, if we see, yep, there we go, here we can already see what exactly is the issue. The issue is this is an integer, and this one is also an integer, and if you divide one int by another int, the result is going to be an int, and you cannot represent 0.9 in an int, so that is why it basically ignores everything after the decimal point, and ends up just returning 0. So the solution here is let's do some math using floats. So we can just cast one of these onto a float, and doing so, float divided by int, the result will be float, which will be 0.9 as intended. So yep, let's test. Okay, there we go, he moves up, he aims, he shoots, and there you go, now it is correct, 0.9, 0.7, 0.6, and so on. Yep, there you go, now the health amount is correctly updating. Alright, awesome, that fixes our problem, so congratulations on solving this, let's move on to the next one. Hello and welcome, I'm your Code Monkey. Alright, so here let's learn how to design a nice quest system. As always, let's follow the steps in our design problem solving framework. So first, let's identify what exactly is a quest system. I would say a quest system is something where we can define quests, then we can allow the player to pick up those quests, and then we have custom logic for each quest to complete. You would say that's a nice general definition of a quest system. We want to have not just one quest, but multiple different quest types. We want the player to be able to pick up those quests, and then each of those quests obviously is going to be different, like pick up one thing or move a certain amount. So each quest is going to have custom logic to complete. So if that's our definition of what is a quest system, now let's go ahead, break the problem down into its core components. So go ahead, pause the video right now and try to do that. Okay, so from this, based on this definition of the quest system, let's say, first of all, we need to define what is a quest. So we need to define some kind of data structure, something that we're going to store that. So what exactly is a quest? Then we're going to need to define some sort of quest system. This one is going to store, add, and remove individual quests. Then we also have the very important part, so the custom logic to complete each quest. So if we implement those three high-level components, then we do have the quest system working. That's our step 2, so now let's go into step 3, so a high-level overview on how to solve each of those components. So based on this, pause the video right now and give that a go. So out of these, I would say, so first of all, for defining what is a quest, for that, we're going to use a scriptable object. There are many ways to do it, but over here, I want to use a scriptable object. Then for the quest system, so this is going to be a quest system class. We're going to have some add and remove functions. And this one is going to store a list of quests SO. And then on the custom logic, so this is the really important part. So we're going to basically have, so each quest extends quest SO. So So basically we have a base class, the quest SO, and then we extend it and add custom logic to it. And for that custom logic, we're going to have some kind of start quest function. And on that function, we're basically going to listen to events to handle the completion. So let's say if the quest is picking up certain amounts of items, we're going to hook onto that event the on item picked up. And using that, we're going to define, did we finish the quest or not? And then basically those events complete the quest, which then tells the quest system. So about to say here, we have a nice structure for what we can build to implement this quest system. So again, first of all, we're going to have a quest SO to define what exactly is a quest. Then the quest system is going to be pretty much a very simple class, just containing a list of the quests, adding and removing them. Then the important part is going to be the custom logic for each quest. So for that, we're going to do custom classes that extend upon the base quest SO. Then we're going to have a function to start a quest. And on that function, we're basically going to listen to events that handle the completion of that quest. And then those events, when they do complete the quest, we then tell the quest system, which then basically removes the quest from the list. So that's it. This is our nice overview of what exactly do we want to build. So over here, we've got the nice quest system demo. And on this one, yep, I've got the character that I can move around. So the usual quest system. So the usual movement system. Then I've got some items in the world. I can approach and I can pick them up. And this over here is basically using the inventory system that we created previously in this course. And then we've got here two NPCs. They've got the interaction system, so I can approach, I can interact with them. And over here on the interaction, that is when I'm meant to actually pick up the quest. And then again, the quests, each of them has different thing. We're going to make a quest for picking up apples and one quest for just basically moving around the world. Okay, so again, based on design, let's first create the scriptable object, so a new mode of behavior for the quest SL. Now on this one, so instead of being a mode of behavior, we're going to make it a scriptable object and get rid of all of this. And importantly, like I said, this is going to be the base class that we're then going to extend upon. So let's make this an abstract class. We never want to create exactly this one. That is why also we're not going to add the create asset menu. Nope, and then over here, based on our design, we want this to have a start quest function. So let's do that, a public void start quest. We're going to have that kind of function. Let's mark this as abstract as well, so the others have to implement it. Okay, great. So now we can start to create the first individual quest. So let's create another mode of behavior, call it quest SO, and then call it get 5 apples. So basically that's the quest. We want to be able to pick up 5 apples. Okay, so now on this one, again, first of all, this is the quest SO, so that is what we're going to implement. And we're going to need to actually implement the abstract class, which involves the start quest function just like that. Okay, so that's good. And then this one, this is something that we do want to create. So let's do a create asset menu, just create it like that. So you have this, and then over here, let's just do debugging log start quest. And this is the quest that we want to start. So let's just first of all verify that this is working. So then we can integrate this with the interaction system. So first of all, let's actually create it. So let's make a folder for the quest SO. We're going to create all of these. So let's create a new, let's go inside the quest SO get 5 apples. Okay, create this one right like this. So this is our quest. Okay, great. And then on the NPC itself, so this one has the nice NPC script. This one over here already implements iInteractable. So yep, that makes sense. Over here, let's add another serialized field for the quest SO. And then when we interact, let's just go on the quest SO and start this quest. So yep, just like this. And over here we have that one. So let's say on this NPC, let's make sure, yep, it's this one over here. Let's just drag this reference. So that's the quest that we want to build. Okay, just a quick test. So here we are, approach that one, interact. There you go, start quest. Okay, so far so good. So now based on our design, so we want the quest system. Let's handle that in a little bit. Now let's actually handle this one. Listen to the events, handle completion. Let's first do that and then handle the quest system. So for the events, let's see the inventory system. This one over here, yep, this one does contain this event. So we can basically listen to this event. This is fired whenever we add an item. So we can see when we add that, do we have 5 apples in the inventory? If so, we complete. If not, then we don't. So the inventory system is over here on the player pickup. So this script, we've got a static instance, and we have the inventory system that we can grab, so we can use this. So over here on this one, on start quest, let's go on the player pickup. Let's grab the static instance and then get the inventory system. So we have this inventory system. So we have this one. Then on this one, let's listen to this event. So when that one changes, then we're going to do something. And by the way, here we can define either a complete function, or we can actually just use lambda. So let's do that just to be slightly different. So just like this, this right here is valid code. We just need to do the lambda like that. Okay, so yep, so we have this event fired when the item is always changes. So now we can go on the inventory system and check get the item amount. And then we need to keep track of the item SO. So let's make another here. Let's make a public in our scriptable object for the item SO, the Apple item SO. So we have this one, we get the amount on this one, and then check if this amount is bigger or equal to 5. If so, then complete the quest. So let's do debug log, and over here, let's just say this is our quest completed. Okay, so just like this, it should already be working. Over here, let's just do debug log, saying item picked up. Okay, great, like this. So now we just need to assign the apple SO over there. So on the get 5 apples, let's drag that one. Okay, now we can test. So here we are. Let's go ahead and let's pick up the quest on the console. We start the quest. Okay, now I pick up 1. And there you go, item picked up. Now 2, 3, 4. And as I pick up the 5th one, and if there you go, quest completed. All right, awesome. Everything is working. So now we really just need to handle the quest system to keep track of all of our quests. So over here, let's just do a private list, a list of type quest SO for the quest SO list. Then just do a public void add quest, receive a quest SO, then go on the quest SO list, and let's add our quest SO. Something like this, we're going to have an error if we don't initialize this. So let's go ahead and make a private void awake and do quest SO list equals a new one. Okay, so that adds it onto the list. And then public void complete quest, which is really just removing the quest. So quest SO, really just the quest SO list. Let's remove this one right here. So yep, basically like this. And now on the quest SO over here on this one, let's go on the quest system. And first of all, we need to access the static instance. So let's do that. Public static quest system for the instance with a get and a private set. So we have this, and over here, let's set instance equals this. So now we can go on the instance and call add quest and pass in this one. And then when we complete, go on the quest system.instance and complete this quest and pass in this one. Okay, yep, so that should do it. Except for one thing, which is over here, if we leave it like this, then basically we're attaching a listener to this event and we're keeping it all the time. And if you do it like this, it's going to basically, it's not going to throw an error, it's basically going to constantly complete the quest. That is not intended, so we need to make sure to unsubscribe to this event afterwards, which if we do it like this, we can't really do it because we're defining the lambda right here as an anonymous function. And just like this, we don't have a reference to this object over here, so we need to do it slightly different. So this one over here, this is an event handler, so we can define an event handler, and we're going to name it exactly like that. So event handler, and name it this on item SO change, and just need to add using system, okay? So then we go on the inventory system, and on that one changed, let's add that event on item SO is changed. And then when we complete the quest, go into that one and unsubscribe to it. And actually, in order to get this reference to work, we need to make sure to define this one as null first of all. And then we can set it like this. And yep, now like this, the code does work. Okay, yep, so that's awesome. So like this, let's go on the quest system and try to see as we add and complete quests. So let's do a debug.log. So quests. Let's do quest list SO list.count. Try to see how many do we have, like this. Okay, so now as I pick it up, and if there you go, I've got one quest, makes sense. And if I go pick up 1, 2, 3, 4, and 5, and there you go, quest back to 0 because we completed. All right, awesome. So just like this, we already have our core system fully built. So we defined what is a quest using a quest SO. Then we defined the quest system with the various functions that we need. Then we made custom logic for each individual quest. So we really just have a system where we extend upon the base class. Then we can start a quest, listen to those events that handle the completion. Then those events, they complete the quest, which then tells the quest system to complete the quest. So yep, just like this, can approach, pick up a quest, and over there on the console I can see, I've got the quest started, and it's listening to those events, and I can pick up 5 apples. There you go, quest completed. Now I can pick up some more, and nope, doesn't do anything else because the quest has been completed. So yep, awesome. Here it is, our fully functioning quest system. The only thing missing is, of course, just the UI. We need to listen to those events on the quest system. And then over here, the exclamation point, we need to update that one depending on whether we pick up the quest or not. But yep, the core logic is working. The core thing for this system is really this. Basically, we made a base quest SO, and then we extend upon with each individual thing. And this one in particular, this one is all about picking up various apples. So this one, we start the quest, we pick up the various apples, and everything works fine. Right, awesome. So now based on this demo, let's start solving some problems. Hello and welcome, I'm your CodeMonkey. Alright, so here's a quick recap overview of the quest system demo. Alright, so here I've got a player character that I can move with WASD. Then I can see there are 2 NPCs in the world. They've got the nice exclamation point on top of them indicating they do have quests available. So I can approach them and I can use the same interaction system that we covered previously in this course. So I can approach, I can press on E to trigger an interaction. And as I interact with this one, yep, there I go, basically gives me a quest. So this one, the quest is get 5 apples. So over there I can see the quest type. I can see the NPC currently has a pending quest, that is why the question mark. And then based on the name, I need to do that task. So in this case, pick up 5 apples. So there are a bunch of apples over here. So I can go ahead and pick them up. And there it goes, I pick up 1. I can see the progress over there increasing. So I've got 20% because I picked 1, 2, 3, 4. And if there you go, 80%. Now as I pick up 1 more, I'm going to complete the quest. And as I go, and if there you go, I finish that quest. And that quest is now done. There's another quest down here. This one, again, I can talk to it. I can get the quest. This one is walk 50 meters. So literally, I just have to move. And as I move, I'm adding progress onto the quest. And if I move up to 50 meters, then as soon as I get there, yep, there you go, quest complete, and it's all done. Right, awesome. So that's the quest system. That's how the demo is set up. Now let's see all the scripts that make this work. So over here in the project files, we can see all the scripts for our quest system. And some of these are things that we've already seen previously in this course, like for example, the inventory system, the item holder, the item SO. So yep, we're using the same inventory system, and we've got the Apple item. Then we've got the interactable system and the player interaction system. So these are part of the same interaction system that we covered. So again, these really just check for things that are interactable around the player and enable some kind of interaction. In this case, the interaction is handled over here by the NPC script. And this one over here implements interactable, again, just so it's interactable. And then we've got a reference to the quest SO. So this is a scriptable object that defines basically a single quest in the quest system. And then over here, the logic for this NPC is really very simple. It's really just a handful of lines of code. And we've got the main interaction function. Again, this is the thing that works with the interaction system. And here it just checks on the quest system. Does it already have this quest active, or has this quest already been picked up? And if not, if it's the first time, then it goes ahead, adds that quest on the quest system, and then really just waits for it to complete. And for updating the text mesh, really just over here, just some simple code. So the quest system, that one fires off an event when the quest list changes, meaning when a quest is either added or completed. And when that happens, just goes on the quest system, try to see, does it still have this quest active? If so, show a question mark. If not, show either an exclamation point, if the player has not yet picked up the quest, or if the player already picked up the quest and the quest has been completed. If so, just show nothing. So you have the NPC script over here, very simple. The core of the quest system is really on the quest system script. And here it is. So yep, this is a normal mono behavior that we have attached in the scene. We've got a nice singleton pattern just to make it easy to use. And we've got two nice events. So when the quest list changes and when the progress of any quest changes, then we keep a list of quests SO. We're going to see how this is set up in a little bit. But yep, so basically this is the list of active quests. And then just a bunch of functions to test, do we have a quest? Can we add a quest onto it? Can we complete a quest? Get the quest list, and so on. See, if the quest system itself, this one is really very simple. And the most interesting part about this quest system here is really the quest SO, the scriptable object. So you can see over here how it's set up. So that's the main quest SO. And this one over here, note how this is an abstract class, meaning we never actually use this original scriptable object. This one is never used. This is really just the base upon which we expand upon to get the other specific quests that each has their own way of achieving it. So in general, we're going to have some kind of string for a quest title, then a function to start the quest, another one to get the progress. But again, this one is abstract, so this original quest SO, this one is never actually created. Instead, we have basically other scripts that extend upon that one, and that is what contains the actual logic for the quest. For example, the one about getting 5 apples. So here it is, this one is something that we do create, and this one does extend the quest SO, the base scriptable object. And here's where we have the specific logic for this one specific quest, the one that is getting 5 apples. So this one specifically, this one contains a reference to the item SO, so that is the Apple item SO. And then the function to start the quest, which again, back on the quest system. So when we add a quest, we add it to the list and we call that function the start quest. And then over here on this one, we really just get the inventory system for the player, because again, the goal for this one is to get 5 apples. So we grab that one. Then in order to figure out, has the player picked up some apples? For that, we're going to listen to the on item SO list change, that event on the inventory system. And when that fires, basically it's going to run this code. And over here on this code, we're going to check, does the inventory currently have more than 5 apples? If so, then we're going to complete the quest. And then just unsubscribe to the event just so we don't keep firing, don't keep completing the quest. And every time we pick up something, we'll just trigger the quest progress change just so the UI updates. And then for the get progress, very simple. Here we just have to pick up 5 apples. So just go grab those and divide them by 5. So yep, this is how the code is set up. So each quest has their own scriptable object, and each of those has a list and basically keeps track of their completion rules. Then for the other quest is the walk 50 meters. And this one over here, also a very simple quest. So this one also extends quest SO. Then we've got a variable to keep track of how much the players moved, and then some certain maximum move amount. Then we've got the function to start the quest. And this one over here, this one is going to listen to an on update event. And this one's basically fired on every single update. That way we basically have this quest logic running on every single update, because remember how these are scriptable objects. So by default, this one over here doesn't actually have an update because it's not a mono behavior. So in order to get that, in order to have quest logic that we can test for every single update, for that over here, I'm just listening to another event. So this is really just a simple event on this script and literally just something that is invoked on every single update. That's it, super simple. So based on that, over here, we can hook onto that and we can run all kinds of logic. So in this case, just calculating the movement delta. So just seeing how much the player moved since the last update. And then we just add that onto the move amount and then just some basic logic. So if the move amount is bigger than maximum, we complete the quest and unsubscribe from the event. So yep, that's it. Also very simple script. The quest system is all based on this, based on extending upon the original quest cell. And then finally, we really just have the quest system UI. So this one is over here on the canvas. We've got the quest system UI and we can look at it. And basically this one really just keeps track of a list of our quests. So as usual, we've got a container, and inside we've got the template. Then on the quest system UI, on this script over here, again, just reference to the template and the container. And here we just hook onto the events fired off by the quest system, and using those, we basically just update the quest list. So we first clean up the container, so we destroy all of the previous objects. Then we cycle through the new quest list, and really just spawn them all, and then update the text using the quest title as well as the progress amount. So with that, we can go ahead, pick up some quests, then achieve their goals, and everything works fine. Alright, awesome! So this is how the quest system is set up. Now based on this scenario, let's start solving some problems. Hello and welcome, I'm your Codemaki. Alright, so let's solve a problem on the quest system. Let's solve problem 1902, starting quest error. So first of all, let's identify the problem. Okay, so apparently if I try to start the quest, it throws an error. So if I approach one of these NPCs, press on E, and if there you go, we've got a null reference exception. So yep, we have identified a problem. Now go ahead, pause the video and try to locate it. As always, since it's an error, it's easy to locate. Let's just go straight into this line. And okay, so over here, this one is returning null. And right away, instantly, I know what exactly is null because over here, only one thing can possibly be null. We're accessing a function, so this one has to be null. If we do a debug, we should be able to see how the quest SO, this one is marked as null. Okay, so as I go and I approach, and if there I go, that one is indeed marked as null. Okay, so yep, we have located the problem. Now go ahead, pause the video and try to fix it. So over here, we can basically see where this function is being called, so we can find all the references. And we can see, okay, so it's being called from here, from the interaction system. This is the interaction system that runs on the NPC itself, and this one contains a serialized field for request SO, which is then passed on to that one. So based on this, I would say the fix is to go on the NPC itself, then look in the inspector, and if there you go, there's the issue right there, so the quest SO, this one is not assigned. So let's make sure to assign this as something. Let's select the get 5 apples quest, and now if we try again, and I can go, I can approach, press on E, and if there you go, it does work, and the rest of it, yep, everything works, I can pick up the 5 apples, and yep, I've got the nice quest. Alright, awesome! So yep, here we have fixed the problem. It was just an issue of a reference not being dragged, and by default, that returns null. Okay, so congrats on solving this problem, let's move on to the next one. Hello and welcome, I'm your Codemaki. Alright, so let's solve a problem on the quest system. Let's do 1903, quests do not progress. Okay, so let's first of all identify the problem. And okay, so let's go ahead, pick up a quest. Okay, we've got the get 5 apples quest, and if I go and I pick it up, and if there I go, okay, that's the issue. That one is staying just on 0%, it is not increasing. And if I go and I pick up the other quest, so let's grab this one, walk 50 meters, so as I move, yep, that one should be adding progress, but nope, it is not. Okay, so yep, so that's the issue, we have identified the problem. Now pause the video and try to locate where the issue might be. So over here, actually, before I try to locate the issue, I actually want to do one more test. I did notice how as soon as I picked that one up, that one actually updated. So it is not updating. So based on this information, I would say the issue has to do with updating and not with the actual quest system itself. And as a way of testing out my theory, I'm going to grab a bunch more apples and try to see if that quest does get completed. So as I pick it up, one, another one, another one. And okay, so that one is not being completed. And as I move and walk 50 meters, okay, that one is not being completed. So either my theory is wrong and the quest is not being completed, or it is being completed, just not updating the UI. Let's get some more information on what might be the issue. So let's go inside the quest system. And over here we have functions for adding a new quest, completing quests, and so on. And we can go, for example, over here on the get 5 apples quest. And on this one, let's see, first of all, if this one is working. So we start a quest, and then we've got our next event when the item SO list changes. So let's make sure this event is being fired. So let's print out this, and let's also make sure that the inventory is actually grabbing the components. So let's also add just the amount, just so we see the number. Okay, let's see. So first, let's accept the quest. Let's pick up one apple. And nope, we don't have any message. Okay, so that's interesting. That means this event over here is never being fired. Let's make sure this function is actually being called so we can see if the error is over here on this one or on the inventory system. So let's see if the start quest actually starts. So as I go and I approach, and okay, so that's the issue. So the quest is actually never starting. We can see where this one's actually being called, just find all references. And if that's the issue, it is actually never being called. So yep, with that, we have located the problem. Now go ahead, pause the video and try to fix it. So over here, we just need to figure out where we need to start the quest, and it probably should be on the quest system itself. So over here, when we add a quest, we probably should actually start that quest. So let's go on the quest SO and simply call start quest. And yep, this should make it start, so let's go ahead. Now as I go and I press on E, and there you go, we've got the start quest. And as I go, and yep, there you go, now we can see the progress is indeed increasing. And after a while, yep, there you go, completes. And this other one, yep, this other one, same thing. I can walk around and the quest eventually will be completed. Yep, there you go, just like that. Alright, awesome. So yep, we have fixed the problem. It was just an issue of a function not being called. So congrats on solving this problem. Let's move on to the next one. Hello and welcome, I'm your Kudmaki. Alright, so let's solve a problem on the quest system. Let's do 1904, one quest not working. Okay, so first of all, let's identify the problem. So apparently the wonking quest, that one is not working. So let's go ahead, pick it up. This is the one from the zombie. We can grab it. Okay, that's great. And now as we move, we should be able to see some progress. And as I move, nope, there's no progress whatsoever. So there you go, we have identified the problem. Now go ahead, pause the video and try to locate it. Now, first of all, before I add some logs, I really just want to move a little bit more just to see if that one is actually progressing, just not updating the UI. So if I move a little bit, if I move way too much, technically that one should disappear, but nope, it is not disappearing. So perhaps it's a UI issue, perhaps it's not clearing up an actual completed quest, or perhaps actually not tracking the walking. So for that, let's go on the walk 50 meters script. And over here on this one, let's make sure start quest is actually running. So let's do a log on this one, make sure the code is coming here. And then over here on the onUpdate event, let's also do a log on this one. So onUpdate, make sure both these are running. And then let's also do a log on the move delta, trying to make sure that this compilation is working correctly. So just print that one, just that one, let's say the magnitude, just so we can see if this one is working. Okay, let's test. Okay, here we are. Let's go ahead, pick it up. And as I walk, or actually, first of all, on the console, we can see, yep, the start quest, that one did run. So now the onUpdate, that one should be firing, and right away I can see it is not firing, and as I move, nope, there I go, nothing is happening. So if we have located the issue, this code over here is not running, which means this event, this one is not being fired. So yep, with that we have located the problem. Now go ahead, pause the video and try to fix it. Over here it's actually very simple. Let's go inside this one and see why is this one not being fired. And the answer is, if we look for references, nope, there are no references because nope, this one is just not being fired. This one's called onUpdate, this one should be fired on the update. So over here, let's just invoke this event. So with the usual thing, this and event args.empty. And if like this, let's test. Okay, and let's go ahead, pick it up. And right away, we can see the onUpdate, that one is working. And as I move around, yep, there you go, the progress is increasing. And eventually, if I walk around enough, it will complete. And yep, there you go, everything works. All right, awesome. So yep, with that, we have fixed the problem. It was just an issue of an event not being fired. So congrats on solving this problem. Let's move on to the next one. Hello and welcome, I'm your Kudmaki. Alright, so let's solve a problem on the quest system. Let's do 1905, one quest finishing too fast. As always, first of all, let's identify the problem. So over here, let's go ahead and pick up the quest. Okay, we have it. And right now it's on 0%, that's great. Now if I move, I should be able to move for about 10 seconds before 100%ing. So now if I move a little bit, okay, there you go, that was way too fast. So if that's the issue, the quest is finishing way too fast. We have identified a problem. Now go ahead, pause the video and try to locate the issue. So over here on this one, let's go inside the quest script. And over here, let's see, basically the issue is somewhere over here in this event. We can see we were adding progress, so we can be pretty sure this one is actually running. But then over here, this logic seems to be running perhaps way too fast. So one thing that could cause that is if this event is being fired multiple times on the same frame. So we can do a log on this just to verify that. So onUpdate, and then we can print out the time.frameCount. And this one should basically give us just one unique number per frame. If we see multiple of the same number, if so, that means this event is being fired multiple times on the same frame. Okay, so on the console, if I pick it up, and okay, so all the numbers are unique, so it is not that issue. All the updates are being fired just once per frame, so that makes sense. Okay, if that's not the issue, then it might be somewhere over here on this math. Let's do a log over here on the movement delta, try to see what this one says. For example, if I'm static, this one should say 0, and if I move a little bit, it should be a very small number. Okay, let's go and pick it up. Okay, so far it's on 0, and if I move just a little bit and stop, okay, so there you go, that's the issue right there. I moved a little bit and then I stopped, but even though I stopped, that one still had a non-zero value. Meaning this one is actually not calculating the delta itself, it seems to be calculating something else because delta, that one should reset to 0 on every single update. So if the issue is somewhere over here in this math. Yep, with that we have located the problem. Now go ahead, pause the video and try to fix it. And over here I've already seen what exactly the issue is. So we're calculating the movement delta by taking the current position and subtracting the last position. And if that works, that's how we get the delta. However, for that to work, the last position, this one needs to update. And right away I can see, yep, that's the issue. So last position, this one is being set over here before we fire the event. But over here on the event, after every single update, we need to make sure to update this. Otherwise, the move delta, that one is always going to be comparing until the position where we were when we started the quest, and that is not what we want. We want the last position from the last frame. So after we do the math, let's just update it. So the player interaction system, the instance, and let's grab the transform position. Yeah, there you go. Now like this, now it should be updating correctly. So let's test. Okay, so let's pick it up, and so far it's on 0. Now if I move and I stop, it should say something, and then back into 0. So move, stop. And if there you go, as we can see, it got a very tiny value, and now back to 0, and that one over there, now that one is working correctly. So I gotta move quite a bit, and if I stop, that one stops going up. So there you go, now it is indeed only tracking movement exactly as intended. Alright, awesome! So we have fixed our problem. It was really just an issue of our math being incorrect. We were not correctly calculating the movement delta. But yep, now it's solved, so congrats on solving this problem. Let's move on to the next one. Hello and welcome, I'm your Code Monkey. Alright, so let's solve a problem on the quest system. Let's do 1906 multiple quests. So on this one, apparently there's an error, so you can't pick up the same quest multiple times. Okay, first of all, let's identify this problem. Okay, so let's go ahead, pick up this quest. Okay, I got it. Now if I press on E again, okay, so that's the error. I should only be able to pick up a quest just once, but I can pick it up as many times as I press the button. So yep, that's a bug. We have identified it. Now go ahead, pause the video and try to locate it. So first of all, for locating where the problem is, let's try to follow our code. Try to figure out where are we having the interaction and where are we actually adding the quest. So we can go, for example, on the quest system. And over here, we can see we have an add quest function. So let's find all references to this one. And we can see, okay, so it's being called from over here, from the interaction system on the NPC. And actually, just like this, we can already see the issue. So we're calling interact, and every time we interact, we are constantly adding the quest. We're not adding any checks, anything. So if the issue is actually right here in this line of code. With that, we have located the problem. Now go ahead, pause the video and try to fix it. So over here, the fix is super simple. We really just need to add some validation. And actually over here, I already have a nice boolean that keeps track of whether we have picked up the quest or not. So we can just check. So if has picked up test. So if this one is not yet true, if not, then we add it. If it is already true, then we already have the quest, so let's not pick it up. Or alternatively, of course, we could go on the quest system, the instance, and check if it has this quest SO. And if it does not have it, then we add it, and then we say we picked it up. This is probably the better way, since this boolean is slightly separated from the quest itself. Whereas this way we have one source of truth, the quest system. We check, do we have the quest? If not, we add it. If so, we don't add it. Simple like this, let's test. So over here, let's go ahead, approach, press on E. Okay, now press on E some more. And there you go, I'm no longer picking up the quest. So I can only pick up each quest just once, exactly as intended, and everything else works. Alright, awesome. So yep, it was just an issue of missing some validation. With that, we have solved this problem, so congratulations, let's move on to the next one. Hello and welcome, I'm your Code Monkey. Congratulations on reaching the end of this free course. I really hope you took the time and actively did all the exercises. Remember how I really cannot force feed you this knowledge, you have to put in the effort in order to learn. So I truly hope that you did that. In this free YouTube video, you'll learn about my 2 problem solving frameworks. You'll learn how to solve technical problems and also how to solve design problems. If you did everything, then you basically went through 20 technical problems and 4 design problems. So with all that, I really hope you'll learn a lot. Now if you want to keep learning more, you can follow the full premium course link in the description. That one contains over 200 technical problems for you to solve. It includes all 15 scenarios. And of course, all the other bonuses like the live chat, the private Discord, live streams, and the question priority. So if you can afford it, then go ahead, pick up the full version. But if you can't afford it, then that's fine. I truly hope you'll learn a lot from this free video. Just go ahead and like the video and subscribe to the channel. It's a tiny thing, but it really does help. Alright, so I wish you the best of luck in your learning journey. Thanks for watching, and I'll see you next time.